Hi, welcome to the first section of the course. In this section we will learn how to use the Ember CLI command line tool and deal with upgrading and deploying a new project. In this section we are going to take a closer look at how to install Ember CLI, how to create a project, ways to explore pods and the folder layout, methods to compile the assets, managing the dependencies, and finally how to upgrade and deploy the project. Here is the first video of this section. In this video we will learn how to install Ember CLI to create an Ember.js application. In this video we are going to first install our Ember CLI using npm. After the installation we will have access to several commands, and for every command there will be an alias which makes it run quicker. We further move on to downloading Bower, which is essential for installing client-side libraries, and also install Phantom.js, which is a scripted headless browser used to automate and test web pages. The installation of Ember CLI is essential to learning Ember, and it will be used throughout this video. Before the installation of Ember CLI, we must have the Node package manager, npm, installed. npm is a package manager for JavaScript and is installed by default with Node.js. You must install version 0.12 or later of Node.js for Ember CLI to run. If you can, try to install version 4.0.0 or higher. This is the preferred version. Node.js is available in several major platforms, including Windows, Mac and Linux. There are several ways to install Node.js, which are 1. One-click installers. Many platforms such as Windows and Mac have this available. 2. Homebrew or Mac ports. This is useful for Mac OS users. 3. Download tar file. Download a tar file of Node.js and extract. 4. Install via the Linux package management system. Yum, apt-get or pacman can be used to install on a Linux environment. Now let's see each of these in detail. A one-click installer for Windows or Mac is by far the easiest method. To install Node, you can open your Chrome browser and enter a link to the Node website. This way we can download Node.js. Under Release, you need to click on the Package, MSI or XE installer for Windows or Mac. Run it after it's downloaded. I have already installed version 4.0.0 here. First we need to click on this version and install the package file. Next we will see Homebrew or Mac ports for Mac in more detail. If you already have Homebrew installed, just run the command brew install node. As you can see, I have already installed it over here. On the other hand, if you are running Mac ports, you can use the port install command, which is sudo port install node.js. Mac ports can be installed from the link. Once the website opens, we need to click on Installing Mac ports. You then need to click on the version of OS you are using. I have clicked on 10.10 Yosemite version in my case. After selecting it, you can save it. Similarly, if you wish to install Homebrew, you can go on this link. So here is the page where we install Homebrew. You can copy this link and paste it in your terminal. I have already installed it for you beforehand. Next we'll take a look at the tar file. A tar file is a type of archive file. To install Node via a tar, you'll need to download the tar file from the Node.js website and extract and install it. One way of doing this is to use curl. I would only recommend this method if you are using a Linux distribution. If you are running on Linux, you'll need the right tools installed to compile from source. On Ubuntu, you'll need to install the build-essential and curl packages. Here are the commands. Since I'm using a Mac, I cannot run these commands. For the Linux package manager, all major Linux distributions offer Node.js packages. In Ubuntu, you can simply use apt-get. For that, we need to run a command, sudo apt-get install node.js. In Fedora, you can use yum. Here is the command for it. Yum install node.js npm. Check with your Linux distribution to find out more details on how to install packages such as node.js. Be aware that some distributions might offer outdated versions of node.js. In this case, I would recommend that you use the Node Version Manager (NVM) installation method that will be discussed in our later videos. Next, we will run the -v command. Next, we will test our installation. For that, we will run the -v command. This command will show the current version installed for Node. To check npm version, we will run the command. Keep in mind that you must run version 0.12 or above to run Ember CLI. If possible, try to run version 4.0.0 or above. Here, I have installed version 4.0.0. The NVM is a bash script that helps manage multiple active Node.js versions. NVM offers a very simple command line interface to install any version of Node.js without having to visit the Node.js website. It separates each installation, making it very easy to change between versions. I would recommend most beginners on Mac and Linux to run this. You can download NVM at this GitHub link. We now know that we'll need to use npm to install Ember CLI. We'll install it globally with the -g option so that it can be run anywhere from the command line. So type the command sudo space npm space install space -g ember -cli and run it. Be patient, it may take a little time. If nvm was installed, you don't need sudo at the start of the command. After Ember CLI is installed, we'll need to download Bower. Bower is a package manager for client-side programming and another essential component of Ember.js. Node.js and npm must be installed before beginning the installation of Bower. We'll be using Bower to install all our client-side libraries. So for that, we will type our command sudo npm install -g Bower. Similar to the last command, you don't need to use sudo at the start of the command if Node.js was installed via nvm. As you can see here, Bower 1.7.9 is installed. So now the last step is to install Phantom.js. Phantom.js is a scripted headless browser used to automate and test web pages. It's preferred by Ember CLI and needs to be installed by typing the command npm install -g Phantom.js and run it. We have successfully installed Phantom.js now. If you are on Windows, install the Ember CLI Windows tool. For that, we'll run the command npm install ember-cli-windows-g. Once installed, this tool can be run in any project directory. You can run the command ember-cli-windows. Make sure to download and install Git for Windows. Here are a few important tips. We will first see how to work with Windows. Build times on Windows can be longer than Mac or Linux. The Ember CLI Windows tool can help speed up and optimize build performance. Just run it in the project directory. You can also download it as an add-on instead. Another way to help with performance is to always run PowerShell/command with elevated privileges. Otherwise, performance issues and errors might occur. Lastly, try to use npm version 3 or higher. You may run into issues with long file paths with older versions in Windows. Another handy tip is how to install Watchman, which is optional. Watchman is a file watching service for OS X and Unix-like operating systems. It was developed by Facebook and is a more effective way for Ember CLI to watch project changes. If it's not installed, Ember CLI will fail back to using NodeWatcher. NodeWatcher is more error-prone and has trouble observing large trees. Install Watchman if your platform supports it. To download and configure Watchman, visit website. We can now take a look at some of the commands and aliases. Once Ember CLI is installed, we'll have access to several commands. Here is a short list of some of the more important commands. Next, we will take a look at a few aliases. Keep in mind that for every command, there is an alias. These aliases make it a little quicker to run commands. Suppose that you wanted to build a new project. Normally you would type the command ember build. This will work and is fine. It will generate a new project and application structure. You can also use an alias as I have done here. Here is a list of some common aliases that you can use. This is optional. Nice! So we have successfully installed Ember CLI in this video. In the next one, we'll build our first project in Ember.js. In the previous video, we learned how to install the Ember CLI. In this video, we'll learn how to create our project. We will start this video by creating a brand new project called My Project. We will then display it on port 4200 simply by running the Ember server command. Finally, we'll learn how to use the --port and --proxy arguments. Let's get started with this new video and create a new project. We'll begin with the Ember CLI tool to create our first project. Open the command prompt and mention the directory where we need to place our project by typing command cd --documents. Now to create a new project, we need to run the command ember --new --my-project. This will create a brand new project called My Project. The project structure will have everything we need to get started. This might take a little time, so be patient. So we created a new project titled My Project. Let's have a look at it. We'll go to the Documents folder where we will see that our file is created. When you click on it, you can see the file structure. Now let's go back to our terminal. To display our project, we can simply run the server command. First, we will navigate to the My Project directory by running the command cd my project. Next, we'll run the command Ember Server. This will start up a web server on port 4200. You can access this port by opening the link http://localhost:4200 on your web browser. You should see the default page Welcome to Ember website. It's a good idea to keep the Ember server running while developing your application. Ember CLI uses a tool called Live Reload to refresh the web browser when changes are made. This can be useful to see how changes are affecting your application. To run Live Reload, we'll open our terminal again and simply type Ember Server. This will start the server with Live Reload. The server command defaults to port 4200 and you can easily change this using the -- port argument. For that you need to type a command. This will start the server on port 1234 instead of the default 4200. This is how you can check it. Another useful option is the -- proxy argument. This will proxy all asynchronous JavaScript and XML, that is AJAX requests, to the given address. Let's say we have a node server running on port 8080. We can run the server by typing the command. Now navigate to http://127.0.0.1:8080 on the browser. For every AJAX request, Ember will now send these requests to the local host at port 8080. Here's an important tip. Keep in mind that as of Ember 2.0, Internet Explorer IE 8 support has been dropped. All modern web browsers and versions of IE after 8 work fine. If by chance IE 8 support is needed, Ember.js version 1.13 has extended browser support and should work with it. The Ember Server command creates a Node.js Express server. This server uses Live Reload and refreshes the web page whenever any changes are made. The server command accepts different arguments, including -- proxy and -- port. When running the server, you have access to tests. After you start the server, you'll have access to the QNIT interface. QNIT is a JavaScript unit testing framework. It is used to run your integration and acceptance tests. To access the interface, navigate your browser to http://localhost:4200/tests. This will show all your tests in the project. From here you can see which tests passed and which failed. We will see this in more detail in our later videos. Awesome! Our brand new project is now ready. In the next video, we'll see how to create the folder structure. In the previous video we covered the process of creating a new Ember project. In this video, Ember CLI will help us create our folder structure using the Model View Controller (MVC) pattern. This video will focus on how to generate a normal folder layout, getting acquainted with different directories, and updating the router with the help of new post model, root and template. Let's get started. This video helps you explore pods and the folder layouts. Ember CLI will create our folder structure for us. Ember.js uses the Model View Controller (MVC) pattern. In this video we will see how the folder structure is laid out and how the model controller and view templates are separated from each other. Ember CLI relies on ES 2015 modules. This means that you can write code today using tomorrow's JavaScript syntax. This is accomplished via the Ember resolver. Let's see what ES 2015 is. ECMA Script 6, also known as ES 2015, is the upcoming version of the ECMA Script programming language. ES 2015 includes several new features including template strings, destructuring, arrow functions, modules and class definitions to name a few. This is all available now within your Ember project. We will now see what a pod is. An Ember pod is a different type of structure that organizes your modules by feature instead of type. As your project grows, you may want to organize your project by feature to help keep things organized. The Ember resolver will look for a pod structure first before it looks at the traditional structure. The first step would be to import our project in Atom and edit each file. As you can see, we have exported our project here. To set up the pod structure automatically, you can edit the .ember-cli file in the root of your project directory. Here is my code for Ember.cli. We have to edit this line and change to true. Use pods true. I will then save this file. This will set the default structure to always use pods. When using pods, it's a good idea to set the location where all pods live. To do this, you will need to edit the environment.js file located in the config folder. Open the file. You can now edit the code after the line var env. Module prefix can now be changed to pod-example. In the next line we will add pod module prefix : pod-example/pods. Instead of example, we can give any name. The pod module prefix property sets the pod path with the following format: appname/poddir. In this example, our poddir is set to /pods. It's in our app folder. If the location is not set, all new modules will be created in the app/folder. So now save this file. After a new project is created, a normal folder layout is generated as shown here. This layout consists of several different types of modules. So let's see each directory with a short description. We look at component. Components are used to help reuse code and must have a dash in their name. -- helpers are used for HTML reuse. -- models will directly hold the data store. -- roots will help move through different application states. -- templates, there is a directory named components. So this is how a new project app folder default layout will look. Each module will have its own directory. For example, the templates folder will store all the templates, while the components controller will store all the components. Let's say that we added a new post resource using pods. So now let's go to our terminal and run this command. This command will generate a new post model, root and template, and it will update the router. Pods sorts directories by features. The post and pods folders are features and the files are named after the function they serve. The directory structure in each Ember CLI project is by design. When creating a new project or generating new scaffolding, the CLI will place files in a certain directory with a certain naming structure that Ember Resolver understands using the ES 2015 format. The Ember Resolver is responsible for the looking up of code in your application and converting the name conventions in the actual class files. With Ember pods, the Resolver knows to look there first before the default structure. Excellent! We just explored pods and viewed the folder layout. In the next one, we'll learn how to compile the assets. Previously, we learned how to create a folder structure using Ember CLI. In this video, we're going to take a look at how to place the assets and CSS files, how to function the minification of both CSS and JavaScript, and how to fingerprint the files or assets. In our application, at some point, you may want to add assets or minimize or fingerprint your project. This is done in the root folder of your project. So let's go to our root folder. We can see our project. Here we will see a file ember-cli-build.js in our root project. So this is how your file will look. We will now see CSS and assets. All the assets should be placed in the public/assets folder as shown here. The assets can be referred throughout the program at assets/images/image file. CSS files should be placed in the app/styles folder, named as app.css. Now, let's see how minifying works. By default, CSS and JavaScript files are minified during the production build process. There are ways to turn this functionality on and off. For example, let's say that you want to turn off the minification for both CSS and JavaScript. To do this, we can simply edit the ember-cli-build.js file shown here. Under the // Add Options Here section, add the Minify CSS and Minify JS section. So here is the code. So we have added this code now. This will tell the compiler not to minify JavaScript and CSS. To build the application in the production mode, simply use the -- environment argument. So we will now go to our terminal and run the code. Now we start with fingerprinting. All files by default will be fingerprinted during the production build process. This will include all JS, CSS, PNG, JPEG and GIF assets. During this process, all these files will have an MD5 checksum appended at the end of their file names. During this process, all HTML and CSS files will be rewritten to include these new names. There are several options available when fingerprinting a file. This is all controlled in the Ember-CLI-build.js file. Let's suppose that you wanted to disable fingerprinting. Here is the code for it. Let's see each line of code. Another useful option is to prepend a domain to all static files. This can be done using the prepend option. Once again, this needs to be added to the Ember-CLI-build.js file in the root of the application folder. Now all assets will include the www.example.com domain. For example, a normal JavaScript source file will look like this. This will be transformed into the following. Another useful option is exclude. This accepts an array of strings. Any file name in the exclude array will not be fingerprinted. The ignore option also accepts an array of strings. Any file name that contains any item in the ignore array will not be processed or fingerprinted. The extension option defaults to JS, CSS, PNG, JPEG, GIF, and map. This option can be used to add other file types to get fingerprinted. The replace extensions option defaults to HTML, CSS, and JS. If needed, new file types can be added to replace source code with new checksum file names. Here is the code for it. So this is how files get fingerprinted. We have now completed our import process via the Broccoli Asset Pipeline library. This build tool performs all the fingerprinting and minifying and importing of the assets. In addition, Broccoli handles all the pre-processors if the appropriate plugins are installed. The asset manifest is located in the Ember-CLI-build.js file in the root of the projects folder. You can only import assets that are in the bower_components or vendor directories. As you can see, I have imported the code for bower_components here. Great, that's about it for this video. We dive deeper into the process of asset compilation. In the next video, we'll understand the process of dependency management. In the previous video, we explored how to compile the assets. We'll see how Bower is used for dependency management and further install the dependencies. Next, we'll see how to load AMD and non-AMD assets, and finally learn how to import and export them. Let's look at dependency management and how we can use it in our Ember projects. Bower is used for dependency management for Ember CLI. Bower is a front-end tool that is used to help fetch and install packages that you might need. Firstly, let's go to the bower.json file. Let's open our Atom project editor. In our project root directory, there is a bower.json file, as you can see here. It contains all the dependencies. Let's say that we want to install the Bootstrap library. Open our terminal window. You can see here that I have provided the path for the project folder here. To install the Bootstrap library, we will run a command. Bower install bootstrap --save, and then enter. This command will install Bootstrap in the bower_components folder and save the package information in the bower.json file. Our Bootstrap library is now installed. So what is the purpose of Ember add-ons? Another popular way of adding third-party libraries to Ember is using add-ons. An add-on is Ember's way of sharing libraries between applications. There are well over 1,000 of them available. You can install add-ons using Ember CLI. For example, to install Bootstrap, you can type the command ember install ember-bootstrap. You can easily find a list of add-ons at these websites. As you can see, add-on list is present on both websites. If for some reason you need to reinstall your dependencies, you can run the install command by itself by typing command bower install. This will install all dependencies that are listed in the bower.json file. Now let's look at the app.import code. Ember CLI allows you to load asynchronous module definition, AMD and non-AMD assets. It's a way of defining code modules and their dependencies. To load a non-AMD asset, you'll need to import it using the Ember-CLI-build.js file, which I've already imported here. The .js file here is our Bower component code. This is useful as you can use Bower to install components and then use the app import AMD so that it's available in the program. You'll need to consult the package specification to see how to use it. Here's a useful tip on JS Hint. JS Hint is a community-driven tool that detects errors and potential problems with JavaScript code. It's built in Ember CLI. When using non-AMD assets, you may get errors with JS Hint if you have global variables. To fix this, add in comment /*global my_global */ and close it at the top of your module page. Here are two comments which are added as an example. AMD assets are imported in a similar way. We add the path in the first argument and a list of exports and modules in the second. I have already added a code here. So if you can see, first we have added the path of the first argument and later we have a list of exports and modules. To use this asset in your application, we'll add one more code. Here the dependency management is done via Bower. After the dependency is installed, the Broccoli library is called on to add the assets to the pipeline. Both these tools are written in Node and are built in Ember CLI. We can now save our file ember-cli-build.js. Great! In this video we carried out dependency management via Bower. In the next video we'll see how to upgrade our project. In the previous video, we learned how to manage the product dependencies. In this video, we learn the best ways to upgrade the project we created. Firstly, we will see how to upgrade the Ember CLI version. Then we will see how to update an existing project. We might come across some deprecations while upgrading the project, hence we will finally see how to handle them. Ember CLI is constantly being upgraded, and every 6 weeks Ember.js has another release. It's important to keep your build tools and versions up to date. In this video, we'll look at the best way of doing this. To upgrade your Ember CLI version, you must perform the following steps. Open the terminal and begin by uninstalling the old Ember-CLI. For that, you need to run the code npm uninstall-g Ember-CLI. Next, we need to clear the npm cache, for which we need to run the command npm cache clean. We would now clear the Bower cache by running the command bower cache clean. Now we need to install the latest version of Ember CLI. You can run the command npm install-g Ember-CLI. I have already done that beforehand. If you need, you can specify the version to use, represented by x.x.x. For that, we need to run the command npm install-g Ember-client at 2.8.10. Let's see how to update an existing project. In some situations, you might want to take an existing project and update it to the latest version of Ember CLI. In this case, you'll need to perform the following few steps. We begin by changing directories that you want to upgrade in the root of the project folder. Delete these temporary development libraries by running the command rm-rf node_modules bower_components dist tmp. Now we have upgraded the directory. Now we will update the package.json file with the version of Ember that we've upgraded using the command npm install Ember-CLI at the version 2.810, which is just an example, --save-dev. x.x.x represents the version of Ember-CLI. The --save-dev arguments will save the information in the package.json file. We now install all the npm and Bower packages again. We can run a command npm install. Since the npm is installed now, we will need to install Bower. For that, we need to run a command bower install. So now our Bower package is installed. The last step is to run the init command, ember init. The init command will create a new application blueprint in your project directory. Follow the prompts and review all the changes. You may be asked to replace existing files. Press D to do a diff of the files and review the changes made. Create a backup of your project before you begin the upgrade process. Since we have already done this process, we won't be doing it again. Keep in mind that after upgrading your project, you might have many new deprecation warnings to deal with. You will see these warnings when you run Ember Server. Each one will need to be addressed. So when you run the Ember init command, you will address these deprecations and view the warnings that the applications provide. For instance, you may get a warning about Ember.view. The warning will describe that Ember.component should be used instead. You'll then need to swap out the affected code with Ember components instead of Ember views. When you upgrade the tool, you are simply uninstalling the node package and reinstalling the latest one. It's a good idea to clear the Bower and node cache as well, so that node and Bower won't have any conflicting packages. When we update an existing project, we first have to make sure that all existing modules and packages are deleted. This is important because when we install the latest version of Ember CLI, some packages might change. After Ember-CLI is saved back in the package file, then you can install npm and Bower again. Running Ember init generates the application structure in the directory that you're in. This is important because some files may have changed since the last upgrade. You can always press D to diff the changes. Now we know how to upgrade our project once the new version is out. In the next video, we'll see how to deploy our application. In the previous video, we learned how to upgrade the project. In this video, we will see how to deploy the application. We would first build our application in order to deploy it, and then we will see how to deploy it using Ember CLI deploy. We would then be using Firebase as a way to host our Ember application. After creating your application, you'll need to be able to deploy it. Let's take a look at a few ways to deploy your application in this video. The first fundamental step before deployment is building your project. To build your application, run the build command. This command builds the contents of the project in the /dist folder. To build your project for production, you'll need to use the -prod argument. You can also designate the default output folder using this command. Building your application for production will automatically minify your files as well as fingerprint them. The /dist folder has everything that your web server needs. At this point, to deploy your application, all you need to do is copy the contents of the /dist folder to your web server. So how does the Ember CLI deploy function? Another great way to deploy your Ember application is to use the Ember add-on called Ember CLI deploy. This add-on helps you deploy your Ember application to a number of different services. It has a very active community behind it, so you can expect frequent updates. As your Ember applications grow, you may want to take a look at this. You can find more information about Ember CLI deploy here. We will finally look at how to use Firebase as a way to host our Ember application. In order to do so, we first sign up for an account with Firebase. This can be done at... Next, we will install the Firebase-tools. After you have a project created and you're ready to deploy, run the Firebase init command in the root of the folder. After running this command, you'll be asked a few questions. It will first ask you to sign into your Firebase account. Enter your credentials to continue. Then it will ask for the name of your Firebase application. Lastly, it will ask for the name of your app's public directory. In most cases, this should be /dist. Next, we will edit the firebase.json file and add some rewrite rules using this code. This is needed to help with navigation in the application. Change my-new-app to the name of your app as well. In the end, all that's left is to deploy to Firebase using Firebase deploy. The Ember CLI build process is compiled using the Broccoli asset pipeline and the build tool itself. It takes all the files and minifies, fingerprints, and organizes them in the /dist folder so that it's ready to be deployed. Many services exist that can host static files. You can use Firebase or just host it in your own Nginx or Apache server after building it for production. This video concludes the first section of this course. We started off with installing the Ember CLI and then creating our first project. We also explored the folder structure and learned how to compile our assets. Next, we introduced dependency management in our Ember projects and learned how to upgrade them. Finally, we saw how to deploy our application. All of the following videos in all of the next sections will demonstrate how to create Ember objects and instances and use bindings, mix-ins, and enumerables. Welcome to Ember.js Solutions by Eric Hanchett, a video course by Pact Publishing. I'm Mark Thomas and I'll be Eric's voice for this course. Eric Hanchett is a software developer, blogger, and perpetual student who has been writing code for over 10 years. He currently resides in Reno, Nevada with his wife and 2 kids. He blogs about software development at programwitheric.com. Okay, so let's talk about Ember.js. Ember.js is an open-source JavaScript framework that will make you more productive. It uses common idioms and practices, making it simple to create amazing single-page applications. It also lets you create code in a modular way using the latest JavaScript features. Not only that, it's a great set of APIs to get any task done. The Ember.js community welcomes newcomers and is ready to help when you need it. Now let's look at our course. We'll start by learning how to use the Ember CLI command line tool. The next section demonstrates how to create Ember objects and instances and use bindings, mixins and enumerables. Later we'll see how to use templates and template helpers. After that we'll learn how to set up your model and work with loading states and redirection. The further section explains how to use properties and manage dependencies between controllers. We then move on to learn how to pass properties, events and actions. Next, we will understand the functionalities of Ember Data and see how to use CRUD records with Ember Data, and also see how to manipulate records and customize adapters. Our next section explains how to create acceptance and unit tests, as well as the Ember inspector. Further, we will discuss how to use services, authentication, bootstrap. Finally, we will learn how to use Ember validations, WebSockets and server-side rendering. This course was recorded using Mac OS X, however you can use Windows or Linux machines as well. You'll require npm 2.x or greater along with Node 4 or higher, which is freely obtainable from http://www.nodejs.org. You will also require Bower 1.4 or greater for this course. This course is for anyone who wants to explore Ember.js and wishes to get hands-on experience making sophisticated web apps with less coding. Will find this book handy. Prior experience of coding and familiarity with JavaScript is recommended. If you've heard of Ember.js or are just curious on how a single-page application framework works, then this course is for you. So, what are we waiting for? Let's begin this journey together, and I hope you enjoy the ride. Hi, welcome to the second section of the course. Previously, we went through the basics of Ember CLI. In this section, we'll learn how Ember.object works and how it can be used in our application. In this section, we will learn how to work with classes, instances, computed properties, Ember observers in Ember.js and bindings. We'll also learn how to use mixins and enumerables with arrays. Here is the first video of this section where we will learn how to work with classes and instances. We start by creating an Ember class and then create an instance for it. We then move to accessing properties within the bulb instance and initializing the Ember object. Finally, we will see how to reopen the class. In this video, we will work with classes and instances. Creating and extending classes is a major feature of the Ember object model. In this video, we'll take a look at how we can create and extend objects works. Cool, let's get started then. In order to do, we need to create our own module and import it in our project. Let's see how to do it. If you see in the atom editor, I've created a new file, myobject.js. When you click on it, you'll see the code for this file. This is the module which you can now import to any file in Ember application. Now you will see each code line by line. Let's begin by creating a very simple Ember class using extend. This defines a new light class with a property called isOn. Light inherits properties and behavior from the Ember object such as initializers, mixins and computed properties. Here's an important tip for Ember Twiddle. At any point of time, you may need to test out small snippets of the Ember code. An easy way to do this is to use a website called Ember Twiddle. Let's check it out. From this website, you can create an Ember application and run it in the browser as if you are using the Ember CLI. Here is the code with the output window next to it. You can even save and share it. It has similar tools such as JS Fiddle, but only for Ember. Once you have defined a class, you'll need to be able to create an instance of it. You can do this using the create method. We'll go ahead and create an instance of light. I've created one over here. Next, we will see accessing properties within the bulb instance. We can access the properties of the bulb object using the set and get accessor methods as shown here. It is one of the property of light class. Let's go ahead and get the isOn property of the light class. This code will get the isOn property from the bulb instance. Here we have added color as an isOn property. To change the isOn property, we can use the setAccessor method here by adding. The isOn property will now be set to true instead of false. Now we will see how to initialize the Ember object. The init method here is invoked whenever a new instance is created. This is a great place to put in any code that you may need for the new instance. In our example, we'll add an alert message as shown here that displays the default setting for the isOn property. As soon as the light.create line of code is executed, the instance will be created and the isOn property is defaulted to false message will pop up on the screen. We will now see what a subclass is. Be aware that you can create subclasses of your objects in Ember. You can override methods and access the parent class using the _super keyword method. This is done by creating a new object that uses the Ember extend method on the parent class. Another important thing is if you're subclassing a framework class such as Ember.component and you override the init method, you'll need to make sure that you call this _super method. If not, the component might not work properly. Now we will learn about reopening classes. At any time you can reopen a class and define new properties or methods in it. For this, use the reopen method as shown here. In our previous example, we had an isOn property. Let's reopen the same class and add a color property. To add the color property, we need to use the reopen method as shown here. If needed, you can add static methods or properties using reopen class, as I have done in this code. You can now access a static property light.wattage, as you can see here. In the previous examples, we created an Ember object using extend. This tells Ember to create a new Ember class. The extend method uses inheritance in the Ember.js framework. The light object inherits all the methods and bindings of the Ember object. The create method also inherits from the Ember object class and returns a new instance of this class. The bulb object is a new instance of the Ember object that we created. So this is entire code for my object.js. To use these previous examples, we can create our own module and import it into our project. To do this, create a new file in the app folder called myobject.js. This is a module that we can now import to any file in our Ember application. In the app folder, edit the app.js file. You'll need to add this line at the top of the file. At the bottom, before the export, add this line. This will execute the myObject function that we created in the myobject.js file. After running Ember server, you'll see the isOn property defaulted to a false pop-up message, and when we click on OK, we'll get a message which says, "Welcome to Ember." Nice! So now we know how to work with classes and instances. In the next one, we'll see how to work with computed properties. In the previous video, we learned how to work with classes and instances. In this video, we'll see how to work with computed properties. We will start this video by adding a computed property to our Ember.object. We will then see how to chain our light object and how to create an alias for it. Let's get started with this new video. In this video, we'll take a look at computed properties and how they can be used to display data, even if that data changes as the application is running. Let's create a new Ember.object and add a computed property to it. I've made the changes in the myobject.js file. We'll begin by creating a new description computed property as shown here. This property will reflect the status of the isOn and color properties. We can now create a new light object and get the computed property as I have done in this code. This example creates a computed property that depends on the isOn and color properties. When the description function is called, it returns a string describing the state of the light. Computed properties will observe changes and dynamically update whenever they occur. To see this in action, we can change the example and set the isOn property to false. We can use this to accomplish our task. The description has been automatically updated and will now display. The yellow light is set to true. We will now see the process of chaining the light object. Ember provides you with a nice feature that allows computed properties to be present in other computed properties. In the previous example, we created a description property as shown here that outputted some basic information about the light object. Let's add another property that gives a full description. Here is our code. The full description function returns a string that concatenates the output from the description with a new string that displays age. In this code, during the installation of the light object, we set the age to 22 as shown here. We could have overwritten any property if necessary. Next, we'll see what alias is. The Ember.computed.alias method allows us to create a property that is an alias for another property or object. Any call to get or set will behave as if the changes were made to the original property. If you can see in the code, there is getProperty, and here we give an alias description. In bulb.get, we make the necessary changes. The alias description alias will display the same text as full description, as if it's just an alias of this object. If we made any changes to any properties in the light object later, the alias would also observe these changes and be computed properly. We'll discuss more about this in more detail in the later videos. Computed properties are built on top of the observer pattern. Whenever an observation shows a state change, it recomputes the output. If no changes occur, then the result is cached. In other words, computed properties are functions that get updated whenever any of their dependent values change. You can use them in much the same way that you would use a static property. They are common and useful throughout Ember and its codebase. Keep in mind that a computed property will only update if it's in a template or function that is being used. If the function or template is not being called, nothing will occur. This will help with performance. Awesome! So now we know how to work with the computed property. In the next video, we'll see how to work with Ember observers in Ember.js. In the previous video, we covered how to work with computed properties. In this video, we'll see how to work with Ember Observer. This video will focus on how to add a new observer and see how to add multiple properties to it. We will also see how to resolve the synchronous issues with the light object and observers. This video helps you to understand how to work with Ember observers in Ember.js. Observers are fundamental to the Ember object model. In the next video, we'll take our light example, add an observer, and see how it operates. To begin, in our app.js, there is a file name light.js. Here is the code for it. We'll add a new observer called isOnChanged. This will only trigger when the isOn property changes. In app.js, you'll see that ember.observer is onChanged code. This will monitor the isOn property. If any changes occur to this property, isOnChanged is invoked. Let's see now computed properties versus observers. At first glance, it might seem that observers are the same as computed properties. In fact, they are very different. Computed properties can use get and set methods and can be used in templates. Observers, on the other hand, just monitor property changes and cannot be used in templates or accessed like properties. They don't return any values as well. With this said, be careful not to overuse observers. In many instances, a computed property is a more appropriate solution. Additionally, if needed, you can add multiple properties to the observer in our app.js file. Just use this code. The isAnything observer is invoked whenever the isOn or color properties change. The observer will fire twice as each property is changed. We will now see synchronous issues with the light object and observers. It's very easy to get observers out of sync. If, for example, a property that it observes changes, it will be invoked as expected. After being invoked, it might manipulate a property that hasn't been updated yet. This can cause synchronization issues as everything happens at the same time. This example here shows this behavior. When isOn is changed, it's not clear if full description, a computed property, has been updated yet or not. As observers work synchronously, it's difficult to tell what has been fired and changed. This can lead to unexpected behavior. To counter this, it's best to use the ember.run.once method. Here is the example for it. This method is a part of the Ember run loop, which is Ember's way of managing how code gets executed. Reopen the light object and you'll see the following. The checkIsOn observer calls the checkChanged observer using ember.run.once. This method gets only run once per run loop. Normally, checkChanged would get fired twice. However, as it's being called using ember.run.once, it outputs only once. Ember observers are mix-ins from the ember.observable class. They work by monitoring property changes. When any change occurs, they're triggered. Keep in mind that these are not the same as computed properties and cannot be used in templates or with getters or setters. Excellent. We just saw how to work with Ember observers. In the next one, we'll learn how to work with bindings. Previously, we learned how to work with Ember observers. In this video, we're going to take a look at how to create an Ember.object and instantiate it. Then we will see how to output our findings. Finally, we will see how to perform one-way and two-way binding. This video will help us learn how to work with bindings. Most frameworks include some sort of binding implementation. Ember is no exception and has bindings that can be used with any object. In this video, we will see how to use them as well as one-way and two-way binding. In a later example which I will show in this video, there is a teacher and a student Ember object. Each has its own set of properties and they both have homeroom. We can share the homeroom by setting an alias for the teacher object. Let's begin by creating a teacher and student Ember.object. Open Atom Editor in the app folder and check that I have already created teacher.js. Click on it and we can see the code. Next we will create a file, student.js, as shown here. The student homeroom is ember.computed.alias, which will bind the homeroom property to teacher.homeroom. Next, we'll instantiate the teacher and student objects. For that, we need to create an app.js file. Here I have already created it. We will see each code now. Here we have mentioned the teacher and student Ember.object with age and grade. The values are mentioned. Here, the Joey object has the homeroom property set to Avery, which is the teacher object that we just created. We can now use console.log to output our findings. As you can see, whenever the Avery object changes its homeroom, the student Joey homeroom changes as well. This is because the homeroom for Joey is an alias for the teacher, Avery. You do not always have to access properties that reference other objects. You can bind to anything. The alias points to name, therefore, when printing to the console, it shows Eric Hanchett for both. Here's an important tip. Ember has a class called Ember.binding. This is a public class that has very similar behavior and functionality as Ember.computed.alias and Ember.computed.oneway. You should use Ember.computed.alias and not Ember.binding. Computed aliases are the preferred method of binding in Ember. Ember.binding is still around and will probably be deprecated at some point. One-way binding. Ember defaults to something called two-way binding. What this means is that when properties are changed in the UI, this is updated back in the controller or component. On the other hand, one-way binding propagates changes in one direction only. For instance, let's say we have a user object with a first name, last name and nickname property. We can use Ember.computed.oneway to create a one-way binding for the first name property. Let's see what happens when we try to make a change to it. Create a new user object with these properties. Instantiate the object and try changing the properties. You can see that nickname does not change even though the user has been updated. You can think of one-way binding like using Ember.computed.alias. However, it only allows you to get values only and not set them. The upstream properties don't get changed when using Ember.computed.oneway. Ember bindings are used in many parts of the Ember framework. They are derived from the Ember.computed namespace. In this namespace is the computed alias method. A computed alias specifies the path to another object by creating a two-way binding. Binding objects don't update immediately. Ember waits until all the application code is finished running before synchronizing all the changes. This prevents unneeded overhead of syncing bindings when values are being updated. One-way binding works by information being propagated only one way. Information does not get updated in the upstream properties. Great, that's about it for this video. We now know how to work with bindings. In the next video, we'll understand the process of using mix-ins. In the previous video, we learned how to work with bindings. We'll go further to deal with mix-ins in this video. We'll see how to create a common mix-in object and using it within Ember CLI. In this video, we'll see how to use mix-ins. Mix-ins are a great way of reusing and sharing code in Ember. Here we will go over some basic operations on how to use them in your code. We will now see mix-in with Ember CLI. Mix-ins work very well with Ember CLI. To start, use the mix-in generator to create one. Let's go to terminal and we need to make sure that we are in our application directory. Let's give the path to the folder. We will now run a command. So now our file has been created in the My Project folder. The generator command creates an app/mixins folder and the common.js file. The common.js file is where we will put the code for the mixin. Now let's go to our project and let's see how our code works. In the folder named app, you will see the mixin folder. There you will see the common.js file with the code. This mixin is exactly the same as the previous example. However, now it's in a module that we can import anywhere, including components or controllers. For now, we'll import it to our app.js file in the app folders directory. If you see, I've already imported the code to app.js file. First, we'll need to add the import statement to the top of the file. This allows us to use the common mixin anywhere in the app.js file. We'll now add the following code to the bottom of the app/app.js file. So here we have the object property. Next is the mixin property. This line of code is set to false and next line to edit. The following line of code will set to true. As you can see, all the properties and methods in the common mixin are available to the object. If we were to add the common mixin to a component, it might look like the code which you can see after clicking on Common Example File in Components folder. As always, we must first import the mixin to our component. The path is always relative to the directory you're in. Therefore, we must use /mixins/common to find it. In the component, I added a simple action called pressed that triggers the mixin edit method. If the action gets triggered, we would see the starting to edit message in the console. In common.js file, this mixin can be added to any object. For the sake of simplicity, all this mixin does is display some text and set the isEditing property to true, as shown here, if the edit function is invoked. Let's see what it looks like when we add this object to an object. The extend method present in Ember.objects allows for one or more optional arguments of the Ember.mixin type. In this code, we added the common mixin to the new Ember.object object. We then instantiated this Ember object using create. All that's left is to output the contents. Use console.log to display each property. This is what the output will look like. As you can see, we can access any of the mixin properties or methods as if the mixin was included in the Ember object itself. This is a convenient way of reusing code in your applications. Let's create another mixin named as second.mixin.js file. Here's the code for it. Now let's see how this looks if we add it to an Ember object. Let's go to app.js file to see it. Now we can have access to both the common and second mixin in our object. We can use console.log to output second property. This is how we add our code. This is the second mixin property. Ember mixin class allows the creation of mixin whose properties and methods can be added to other classes. They can't be instantiated, but they can be added or mixed in. A mixin in computer science is a class that lends or copies its behavior to a borrowing class using composition instead of inheritance. It encourages code reuse and avoids ambiguity that multiple inheritance can cause. Great! In this video, we learn how to use mixins. In the next video, we'll use enumerables with arrays. In the previous video, we learned how to use mixins. We'll go further to deal with how to use enumerables with arrays. We will see how to use for each, map and map by with an array. We then move on to find the first and the last object in an array. We'll have some fun with filters and learn how to use filter by with objects. Next we will see how to use find and find by. In this video, we will see how to use enumerables with arrays. The Ember.enumerable methods are very important when dealing with arrays. We'll take a look at some common used cases in this video. I have already added the code at app.js. To understand how to use enumerables, we must first take a look at the standard JavaScript array methods and their equivalents using observable enumerables. In standard method, we have unshift, shift, reverse, push, and pop, and in observable equivalent we have unshift object, shift object, reverse objects, push object, and pop object. We'll be using some of these methods in our examples, so keep in mind what the standard and observable equivalents are. The Ember.enumerable class has several methods that we can use in our Ember applications. Now we will list some of the more common methods and what they do. So in enumerable method, first one is for each, which iterates through enumerable, calling the past function on each item. Next is first object, which returns the first object in a collection. And the last object returns the last object in a collection. Map method maps all the items in enumeration to show another value, similar to map in JavaScript 1.6. and map_by method returns the value of the named property on all items on the enumeration. We have the filter method, which returns an array with all of the items in the enumeration that as passed function returns true. Next is the find method, which returns the first item in the array that the method returns true, and find_by method returns the first item with a property that matches the passed value. We have every method which returns true only if the passed function returns true for every item in the enumeration, and any method returns true only if the passed function returns true for any item in the enumeration. Many of these methods are similar to their JavaScript counterparts. If you know how to use the JavaScript method, you should be able to use the Ember equivalent as well. Ember.enumerables adds all the nice features of Ember objects to enumerables. We'll take a look at several examples on how to do this. The contents for all of these videos are in the later video folders in the app.js file. We will now see how to use for each with an array. So here is the code for each. A very common use case for an enumerable is iterating over an array with for each. So we have created an array of students. Next, we have used the for each enumerable to iterate over the array. The console output will show each student's name in the array. Template literals. Ember is compatible with the latest in ECMAScript 2015. One neat new feature is called template literals or template strings. Template literals are string literals that can stretch across multiple lines and include interpolated expressions. You can do string interpolation by surrounding variables in your strings, like this, $, curly brace, curly brace. Each variable will be displayed in the string as shown in the preceding for each example. Next, we will see how to use map with an array. The map method takes an array, maps each item, and returns a new modified array. Let's say that we want to make the student names all in uppercase. We can do this using map. Create a list of students as we have done here. The first letter is capitalized. However, we want all the letters in uppercase. Use map to convert every item to uppercase. So here is the code for it. Every item in the array has been converted to uppercase. The new uppercase student array has all the new values. Use the for each enumerable to iterate through every item in the array and display its contents as shown here. The output displays each name in the new uppercase student array. Now we will see how to use map_by with an array. The map_by enumerable can be used if your array is comprised of objects. From each object we can extract its named properties and return a new array. Let's create a teacher and a student object. Here is the code for it. Each object has one property called name. Next, we'll instantiate each object by adding this code. Each object is put into a people array, student and teacher in this case. We can use map_by to create a new array, for which we have used the console log. This new array returned has the values from the name property from both objects. Now we will see finding the first and last objects in an array. If necessary, we have an easy way to grab the first and last objects in an array. We'll begin by creating a student array as shown here. This array has 6 different students: Eric, Jim, Shelley, Kate, Jenny, and Susan. Let's grab the last object in the array. This code will display Susan, the last object in the array. Now let's retrieve the first object in the array. This code will display Eric, the first item in the array. We can now push objects on the array as well. Here is the code for it. The student Jeff has now been added to the list. Now we will see a code to have fun with filters. A very common practice is to take an array and return a filtered list of items. To begin, let's create an array of numbers like we have done here. Now we will take the array and filter it, returning only those numbers over 10. Here's the code for it. Next, we will use console log to display the new array. This new array has numbers only greater than 10 in it. We will now see how to use filter_by with a collection of objects. With filter_by, you can take a collection of objects and filter it by some property. Let's create a new student object that has a name and grade. Add the students to the new array as shown here. Use filter_by to show the students who are seniors. This code returns an array of students who are seniors. We can double check the output using for each code as shown here. Next, we will see code for using find to get the first match. The find enumerable works very similarly to filter, except that it stops after finding the first match. Now we will create an array of numbers. Use array find to retrieve the first number in the list that is over 10 using this code. We'll then check the output of the new array. The answer is 25, as it's the first number in the list that is over 10. We will now see how to use find by with collections. The find by enumerable works very similarly to filter by, except that it stops after finding the first match. For that, we need to create a new student object as shown here. Next, create an array of students. We need to use find by to match only the properties that have grade of senior. This code will return the first student who is a senior. In this example, Jen Smith is the first student who matches this criteria, so it's returned to the new student array. Next, we will see how to learn with the every enumerable. The every enumerable will return true only if every item matches a certain condition. Let's begin by creating an array of numbers. Use the every enumerable to check whether every item in the array is greater than 10. This returns true because every item in the array is over 10. Now we will see how to use any to find at least one match. The any enumerable will return true if at least one item matches a certain condition. Once again, create a list of numbers as shown. Use the any enumerable to check whether any of these numbers in this array are over 10. This code will return true because at least one number is above 10. The Ember.enumerable mixin is Ember's implementation of the array API defined up to JavaScript 1.8. It's applied automatically on page load, so any method is available. In order for Ember to be able to observe changes in an enumerable, you must first use Ember.enumerable. The enumerable API follows ECMA script specifications as much as possible, so it minimizes incompatibilities with the other libraries. It uses native browser implementations in arrays where available. Great! In this video, we learned how to use enumerables. Overall, in this section, we learned how to work with classes, instances, computed properties, Ember observers, and bindings. We also saw the use of mixins and enumerable with arrays. In the next section, we'll see how to use templates and template helpers. Hi, welcome to the third section of the course. In the previous section, we'll learn how Ember.object works. In this section, we'll be using HTML bars and handlebars, and we'll be going over how to use templates in our applications. We'll learn how to define an application template and how to work with conditionals. We'll also learn how to display list of items and the process of binding with element attributes and classes. Further, we'll see how to work with HTML links and how to handle HTML actions. Finally, the video will cover the use of input helpers and development helpers. In this video, we will learn how to work with templates. We will learn how to create a new application using Ember CLI. We later move on to create a new route to add a new template and finally generate a controller. To work with templates, we need to understand the basics on how properties bind with controllers and components. This video will go over how to accomplish this. Cool, let's get started then. To work with templates, we need to understand the basics on how properties bind with controllers and components. In order to do so, we will first create a new application using Ember CLI. You can go to Terminal and give the path of the folder where you wish to place the application. The command will be. We then run this application to generate a new application in the Documents folder that we can use for further videos. We will enter the path to the Hello World app. Next, we'll create a new route that will add a new template. This is the code for it. This command will generate the template and routes files as well as unit tests. The template file is called helloworld.hbs and will be generated in the app/templates folder. The route file is called helloworld.js and is located in the app/routes folder. The route.js file will also get modified with the new Hello World route as shown here. We'll discuss more about routes in later videos. After this, we'll need to generate a controller. So let's run the command. This will generate a new file called helloworld.js in the app/controller folder as you can see here. You can also find a helloworld-test.js in test/units/controllers folder. With all the files created, we're now ready to continue. Now let's take a look at adding properties to our new template file. We will begin by editing the helloworld.hbs file which is located here. Let's open the helloworld.hbs file. You can see the code here. For this simple code, we'll create a string with the first and last name properties as shown here. Handlebar expressions are surrounded by double curly braces and backed by a context. A context is an object from which handlebar expressions read their properties. In this code, the context is the controller. The outlet will render the template of any nested videos, which will be discussed in our later videos. Now let's move to /app/controllers/helloworld.js. The controller will need to have the first name and last name properties so that it can be displayed in the template. Here, the controller has the same name as the template. The template, by convention, will retrieve the properties from the controller of the same name. Each of them is bound to each other. If any changes occur to the data, the other values will change. Now let's see how to use templates with components. Similar to controllers, we can create a component that acts as a context for the template. In the component, we can set up properties that can be accessed by the templates later. We will start by creating a new component for which you can use the generate component command as shown. All components must have a dash in their names. This command will create the hello-world.js file in app/components/hello-world.js folder, a template file in the app/components/hello-world.hbs file, and an integration test file at tests/integration/components/hello-world-test.js. Next, we will edit the hello-world.hbs file and add the hello world string as shown here. Here, the first name and last name parameters are retrieved from the component. The yield expression is used when the component is in the block form. We'll talk more about this in later videos. We will now go to the hello-world.js file in the components folder. We'll add two properties to the component file, hello-world.js, the first one being first name, and the last one being last name. For the last part, all we need to do is add the component that we just created to one of our application.hbs files, as you can see here. The hello-world handlebar expression adds the component to the new application.hbs file. The hello-world template will then be rendered here. The outlet template will render the nested routes under the application route. Now let's start the Ember server. For that, we will first provide the path for application project, which is, and then start the server by adding the command and run it. We can then navigate to the link. After the Ember server is started, open a web browser at localhost 4200. The message on screen will show, "Hello world, my name is John Smith." Next, we'll open a new tab and navigate to the link. We'll be greeted with two messages. The message on screen will show, "Hello world, my name is John Smith." "Hello world, my name is Eric Hanchett." When the Hello World route is loaded, the application template is displayed. The outlet template then gets rendered with the contents of the Hello World template file. This is why both messages are displayed. Remember that all routes are nested under the application route. Ember.js uses the handlebars templating library. This library provides you with a way to do data binding between the component or controller, also known as a context, and the template. This data binding occurs in both directions. In other words, changes to the data in the component or controller will be reflected in the template. Changes in the template to the data will be reflected in the controller or component. In the previous simple example, the first name and last name properties in the component were accessed in the template with double curly braces, like you can see here. This is known as a handlebars expression. The template is just regular HTML with embedded handlebar expressions. Ember compiles these templates later on during the build process. Nice. So now we know how to work with application templates. In the next video, we'll see how to work with conditionals in templates. In the previous video, we learned how to work with classes and instances. In this video, we'll see how to work with conditionals in templates. We will start this video by creating a new project and generating a new controller. We will further update the router file, the controller, and the conditional template. Let's get started with this new video. Using conditionals is fundamental to using Ember's templating engine. In this video, we'll take a look at conditionals and how they work with templates. Let's take a look at a simple example that displays text if some property is true. We'll start by creating a new project as we have done in the previous video. Since we have already created it earlier, we'll go to that folder by typing the command. Then we need to generate a new controller called conditional. Run this command in the root of the application folder to create controller and template. This will create the conditional controller. Next, we go to our folder Hello World app. We need to update the root.js file in the app folder with a new conditional root by using the command. This will add a new conditional root. To access this root using the Ember server, we will first open the terminal and provide the path to the project folder and run the command. Then we will open a web browser and navigate to the link. Once we open this link, we'll get a message as shown. We'll now go to our condition.js file. When you open it, you'll need to update the conditional controller with the isHomeworkDone property by using the command. This will create a new isHomeworkDone property and default it to true. Next, we'll go to conditional.hbs file in templates folder. Here we need to update the conditional template so that it will display one message if isHomeworkDone is true and another if it isn't. For your information, the if statement shown here is a helper and must be surrounded by curly braces, like any other handlebar expression. It begins with a hash sign, which indicates it's a form of block invocation. The /if statement closes the statement. The next example will show two statements, if and else, both in the block form. Only the statement that is true will be displayed. As we know from the controller in conditional.js file, if isHomeworkDone is true, the statement "Thanks for finishing the homework" will be displayed after the template is rendered. On the other hand, if isHomeworkDone was false, the statement "Please finish the homework" will be displayed. To test this example, navigate to the root. The outlet in application.hbs will render the conditional template inside of it. Next, we will see how to use inline invocation with templates. Inline invocation can be used to display data with if statements, all within one line of code. To start with, we'll take the previous example and recreate it using inline invocation. Edit the conditional.hbs file in the app/templates folder with the new if statement using inline invocation as shown here. When using inline invocation, you don't need to use the pound sign or end the if block with /if, as shown here. Everything can be written in one expression. The first argument of the helper after isHomeworkDone, "Thanks for finishing the homework," will only be shown if isHomeworkDone is true. The second argument, "Please finish the homework," will be displayed if isHomeworkDone is false. We will now see how to work on nested invocation with templates. Nested invocations are inline, which means they return a single value. They can also accept multiple nested if statements in the inline helper. In the conditional controller, that is the conditional.js file, we'll add a couple of properties called isHomeworkDone and isChoresDone by using the code. Both of these are defaulted to true. Now we will open our conditional.hbs file. Let's use nested invocation to display a message only if both isHomeworkDone and isChoresDone are true. Edit the conditional.hbs file with the new nested if statement. The "Thanks for finishing the homework" string will display only if isChoresDone and isHomeworkDone are true. Otherwise, nothing is displayed. As the controller has both values set to true, the message will display "Thanks for finishing the homework" after the template is rendered. We'll now see another useful helper, unless. It works exactly the opposite of the if helper. It can work with all three invocation styles, inline, block, and nested. We will open the conditional.hbs file where we'll create the unless block that will display a string if it's not true in our conditional.hbs file. In this block, the unless helper will display "Please finish the homework" only if isHomeworkDone is false in conditional.js file. On the other hand, the message "Thanks for finishing the homework" will be displayed if isHomeworkDone is true. This is essentially the opposite of the if helper. In this code example, assuming that isHomeworkDone is true, the "Thanks for finishing the homework" string will be displayed in the template after it's rendered. The if and unless conditionals are built-in helpers that are made available to us from the handlebars templating engine. They are surrounded by curly braces, which tell handlebars to interpret them. The if statement checks whether the property is true. JavaScript values such as undefined, null, quotes, square brackets, and numeric 0 will return as false. There are three different ways in which these conditional helpers can be invoked: block, nested, or inline. All three will work with if and unless helpers. Awesome! So now we know how to work with conditionals in templates. In the next video, we'll see how to display a list of items. In the previous video, we covered how to work with conditionals in templates. We'll see how to display a list of items. In this video, we will use the Ember server to access the conditional route, iterate the list of items using each helper, and finally render the output. Often, you have a list of items that you'll need to iterate over. We can iterate these through items with each helper. This video will go over how to do this. It will show us how to display a list of items. Let's say that we have a list of students and want to display them in our template. We'll use the each helper to accomplish this. In a project which we have already created earlier, we will first generate student controller and template by using the code Ember.js controller student. This will create the necessary files needed for our code. Next, we'll update the router.js file in the app folder with the new student route. This will add a new conditional route. You can then update the student controller with an array of students as a property. This array has 3 student objects. In our student.hbs template in app/templates folder, we'll iterate through the students array using the each helper by using this command. The first argument to the each helper is the array to be iterated over. In this case, this is the student array that was declared in the student controller. The student block param is what we'll use to iterate over the array. The each helper must be in the block form. In this code, each value of the student will be displayed with an HTML break afterward. Now we will go to our terminal and provide the path to our project. We will then run the Ember server command as shown. To access this route using the Ember server, open a web browser and navigate to. The output will look like this after being rendered. If by chance the array was empty, you can use else. Now let's add a new array to the template student.hbs. This array can be empty or may not even exist. The else block will be rendered only if the array is empty or doesn't exist. Next, we'll see how to find the index of an array. If needed, you can also access index of the array in the second block param. In our student.hbs file, we'll start by creating a new array and add the index block param as shown here. After each iteration, name and index is displayed with an HTML break element. This index can be accessed using the double curly braces index. Assuming that we are using the same student array which we created in an earlier video, the rendered output will look as follows. Please note that the index starts at 0 and not 1. The each helper uses block params to iterate through arrays. The each helper takes an array argument and the block param is used to iterate each individual item on the list. If the array doesn't exist or is empty, you can use else to display a message instead. In this video, the students array was declared in controller. It had several student objects that could be accessed by the template. The template used this array and iterated over it with the each helper. Excellent, we just saw how to display a list of items. In the next one, we'll see how to bind with element attributes and classes. Previously, we learned how to bind with element attributes and classes. In this video, we're going to take a look at how to generate a template and controller for a new project. Then we'll see how to use the new template with an image tag to display URL element. Finally, we'll see how to bind an element to an image source tag. A very useful feature of HTML bars is binding elements to attributes in your HTML. In this video, we will learn how to bind with element attributes and classes. A very simple example would be binding an element to an image source tag. Let's look at how to carry this out. First, generate an index template and index controller on our project which we have created in our earlier videos. For index template, you can run this command. And for index controller, you have to run this command. This command will generate the files needed for this example. Now you can go to the index.js file in the controller folder. Next, we need to create a new index controller file with URL, side class and second class as its properties as shown here. We get the index route and controller without having to create a specific route for them. It works like the application route, which all other routes inherit from. Now we'll create a new template index.hbs like we have done earlier and add an image tag. The URL element will be displayed as shown. This will be rendered as if the URL property is in the source attribute for the image tag. The template will be rendered with the URL property as we can see here. We can essentially add this to any tag we like. Let's create a div tag in our template with a couple of properties added for the class. Both side class and second class will be added to the class attribute. As these properties are bound, they act like any other property in Ember. They can be dynamically changed and the template will render accordingly. Now we will see what a content security policy is. When running examples in this book, you might occasionally see messages in the console warning you about security violations. They'll usually appear in big red text in your console. The Ember team put this in place to help remind developers about potential security issues that your application might have. For the purpose of this book, these warnings can be ignored. On the other hand, you can fix these warnings by editing the config/environment.js file and the content security policy section. You can find examples on how content security works at binding elements and attributes is done by the HTML bars templating library, which is based on the handlebars library. It looks at every attribute with a property and renders it on the screen. These attributes are bound to properties that can be accessed in the controller or component. We can bind any property to any attribute, the only exception being view helpers. We'll discuss this more in a later video. Great, that's just about it for this video. We now know how to bind with element attributes and classes. In the next video, we'll see how to work with HTML links inside templates. In the previous video, we learned how to bind with element attributes and classes. In this video, we'll start by creating a new application and root it. Next, we will add string to application file. Further, we will add a link to helper and display the output. One of the most useful helpers that Ember.js provides is the link to helper. In this video, we'll discuss how to use this helpful feature. This video will focus on working with HTML links inside templates. The link to helper is used to navigate an Ember application. The first argument is always the name of the root. The second is the dynamic segment. We'll discuss dynamic segments a little later. One of the simplest ways to use the link to helper is to use it inline. Firstly, we'll go to our project directory to create a new application. Here is the path for it. We'll start by creating a new student application and root. Run this command in the root of the project directory as shown here. Ember CLI will generate a new root called students. This will update the router.js file as well as add the template and root files. Open the students.hbs file in the app/templates folder and add this string to it. This message will be displayed after navigating to the students root. We will now open the application.hbs file in templates folder. Let's add a link to helper. The link to helper's first argument is students. This is the students root that we created earlier. This will render an HTML hyperlink with the name of students linked to the students root. The outlet tells the handlebars templating library where to render the output of the root. The output of link to will show an HTML link. When this is clicked, the link will display the student's root message that we created earlier in the students.hbs file. This is rendered by outlet. Students is a hyperlink to the root/students. Ember.js is smart enough to remember the history of a link after it's clicked. Therefore, if by chance a user clicks back on the web browser, it will return to the previous root. You can override this behavior if needed by adding the replace equals true option to the link to helper as shown here. Next, we will see how to add data attributes to view helpers. Unfortunately, data view helpers such as link to and input don't allow custom data attributes. In other words, if you're using link to, you can't add data toggle equals dropdown to the end of the link to helper. Normal attributes such as class will work, however. One way to add custom attributes is to reopen ember.link component for link to or ember.text field for the input helper. Reopening a class was discussed in a previous section. The ember.object model, so check there first. After reopening the class, you can add an attribute bindings property array. Each element in the array is a data attribute that you want available to your link to or input helper. For example, to add data toggle as an attribute to your link to helper, it would look like attribute bindings data-toggle. We'll discuss more about input helpers in the next video. Alternatively, you can create a component that extends from link component instead of the normal simple component. You can then add attributes to it. Make sure to name it something other than link2. Let's see how to use link2 helpers with dynamic segments. Link2 helpers can be used to link dynamic segments. The dynamic segment is added to the second argument in the link2 helper. In this video, we'll create a student's root with a dynamic segment. Run this command from the project root to create a resource for students as we have in our previous videos. This will create the model, root and templates needed for our new student's root. Let's go to our project directory and click on the app folder where you can access the router.js file. Next, we'll need to update the router.js file and add a simple dynamic segment. The most important thing to realize here is the path. This is called a dynamic segment and is represented by :student_ID. By convention, the student's root will retrieve information from the student model. Let's go to a browser and navigate to http://localhost:4200/students/5. The root will retrieve the student model with the ID of 5. We can look for more information on dynamic segments and roots in the next section. Create a new application.js file in the app/roots folder as shown here. For the sake of simplicity, we'll have the application root return an array of student objects we can then retrieve in our template. The application root is on top and is inherited by all other roots. For this example, we returned a list of objects with a number of properties as you can see here. This model will be able to be accessed in our student's template. Update the student's template file student.hbs in the app/templates folder. This template will display name, age and location of the model passed to it. Make sure to prefix all the values with model. We'll then update the application.hbs file in app_template component folder with an each helper and link2. In this example, we have an each helper that iterates through the model. The link2 helper has two arguments. The first is the root, which is students. The second is the dynamic segment, student. Ember will replace each segment with the value of the corresponding object ID's property. If for some reason no model exists, you can explicitly set the value instead as shown here. This will link the student's root with a dynamic segment with an ID of 1. Now let's see what multiple segments are. There might be times where you have nested roots with multiple segments. For example, a blog might have blog posts and each blog post might have comments. In this case, you can specify multiple segments in the link2 helper. All you need to do is separate them with a space. For instance, a blog with multiple comments might look like #link2 blog.comment 1 comment comment/link2. The 1 is the first dynamic segment and the comment is the second dynamic segment. After being rendered, 3 links will be displayed as follows. Clicking on any link will navigate to the student's root with that ID. The template will then display the student's information on the screen as follows. The link2 helper is used by the templating engine to route a customer throughout an application. It's only used for internal links, not external. The link2 helper takes 2 or more arguments. The first is the name of the root, the second is used for dynamic segments. Great! In this video, we learned how to work with HTML links inside templates. In the next video, we'll see how to handle HTML actions. In the previous video, we learned how to work with HTML links inside templates. Now we'll deal with handling of HTML actions. In this video, we'll see how to generate a component template and add an action to it. We'll also see how to add action components to an application template. Finally, we'll load the application on Ember Server. Often, in an application, we'll need to allow interaction with controls that affect the application state. To accomplish this, we use actions. The action helper is used on HTML elements to send actions back to the template's corresponding controller or component when the user clicks on an element. Let's take a look at an example code of this. We will access our terminal and create a new project as we created in earlier videos. Next, we'll navigate to the root of the application directory and type this command to generate a new component. Keep in mind that all components must have a dash in their names. This will generate the component template, JavaScript files and test files. Now let's go to our application directory where we will click on the action-component.js in the component folder. Here's the code. Edit the action-component.js file in the components folder. We'll add the action toggle text. In this example, we have a show text property that's defaulted to true. When the action toggle text is triggered, it toggles the show text property. The toggle property method sets the opposite value of its current property. Now go to the app template folder. You can access action-component.hbs file in the components folder. The toggle text action is now ready to be added to the template. The next step is to add the action to the component template using the action helper. Here's the code for it. The if helper will display text only if the show text property is true. The button at the bottom has an action called toggle text next to it. Whenever this button is pressed, the toggle text action will be invoked by the corresponding action component. To keep things clear, the button will show hide text if the text is shown and show text if it's hidden. It's good to know that you can attach an action to any HTML element, but not all will respond. Some browsers may ignore the click event. In this case, we can use this CSS trick as a workaround. We'll now see how to specify the type of event. By default, all actions listen for click events. When a click occurs, that action is triggered in the context, component or controller. You can specify an alternative to the click event with the on option. For example, a button with a double-click action would look like this. All event names must be camel-cased and lowercase when assigned to on. This was just an example, hence we'll go back to the original code. We now need to add the component to the application template file, which is the application.hbs file, so that it can be displayed. This will add our action component to our application template. We will now load our application by typing the command. Navigate to our browser next. After loading the application with the Ember server, it will look as follows. Pressing the Hide Text button will hide the text. Pressing it again will show the text. We will now see how to add a parameter to an action event. You can have arguments in an action handler that will be passed back to the context. Anything after the action name of the action helper will be passed as an argument to the component or controller. Let's go to our terminal. To begin, we'll create a new component. After the project is created, run this command in the root of the project folder. This will generate the necessary component files for our new param component. Now let's access param-component.js file in the app folder and edit it. Next, we will add a new action called pressed. In this simple code example, the pressed action has only one parameter. When the action is triggered, an alert box is displayed with the pressed in parameter text. We now access param-component.hbs file in the templates folder. In this simple code example, the pressed action has only one parameter. When the action is triggered, an alert box is displayed with the passed in parameter text. In this template, we have an input helper. The input helper will be discussed in more detail in later videos. The button press triggers the pressed action and passes the hello text from the input helper to the action. We'll now see how to allow default browser action. The action helper, by default, prevents the default browser action of the DOM event. In other words, when a user clicks on a link or a button that might otherwise reload the page, Ember prevents this. If needed, you can turn this behavior off using prevent default equals false. For example, we can add an action to a link and have it redirected to a page as well as a trigger event. href equals thispage.htm. Action pressed. Prevent default equals false. Press me. The next step is to add param-component to the application-application.hbs. In this code, we added param-component to the application template. After starting the server, a text box will be displayed. Pressing the Press Me button will display the text in an alert box. It should look as follows. In some cases, we may not be using an input helper. Let's say that we want to have an action event trigger on blur. We can specify a value option in our action helper. Let's go to our param-components.hbs in the component folder. The input text file has value equal to the hello property. The onBlur event is raised whenever the element loses focus. By default, the action handler receives the first parameter of the event listener. In this case, it would be event. We must specify the value option to specify the target value using target.value. Unfortunately, due to the way Ember binds values, we cannot simply just send the hello property as a parameter to the action. This is why we must use the value option. The action helper attaches to HTML elements in order to allow user interaction. It sends named events to the template's corresponding context, component, or controller. The action helper by default sends the first parameter of the event listener. You can send any parameter that you want after the action event. If needed, you can specify the value option and use target.value, which will send the target of the event. Great! So in this video, we learned how to use handle HTML actions. In the next video, we'll see how to use template input helpers. In the previous video, we learned how to handle HTML actions. We'll go further to deal with how to use template input helpers. We will see how to use add input helper to an application. Next, we will see how to assign properties to the input helper. We will also see how to create new application controller and assign property to it. Finally, we will add a simple action to the input helper. To create common form controls, input helpers can be used. This video will go over how to use them in our Ember applications. The most common input helper is input. It wraps around the Ember.text field view and is almost identical to the traditional input HTML element. We will start by creating a new project as we have done earlier in the app/templates folder. Open the application.hbs file and add an input helper. Here you can view the code. The input helper is very simple. All it does is set the value of the text box to hello world. It's surrounded by double curly braces and supports the normal input attributes. When rendered, it will look like this. If needed, we can assign properties to the input helper. Let's go to our terminal now. We will now create a new application controller. Run this command in the root application folder. This will generate a new controller that the application can access. Now let's open the controller application.js file and add a new property. We'll call this hello text. We will now edit the application.hbs file again and set value to the property. The hello text property is now bound to the input value. Attributes that have quoted values will be set directly to the element. If left unquoted, these values will be bound to the property on the template's current rendering context. In this case, this is the controller. We will now open the application.hbs file in the templates folder. Let's add a simple action to the input helper. This can be done using the dasherized event name as an attribute to the input helper. Whenever a key is pressed, the action pressed will be triggered in the component or controller. As we haven't created a key press, we'll add it to our controller application.js file. Whenever a key is pressed in the text box, a message will be logged to the console. Let's see how to use checkbox helpers. In the previous example code, we created a simple input text box. We can also create a checkbox in the same way. This uses the Ember.checkbox view. In a new project, open the application.hbs file in the app/templates folder. Let's add a new checkbox using this code. This is very similar to the input text box. Next, we need to generate an application controller. We will open our terminal and add this command. This will be used to store our isChecked property. Let's go to our directory again and open the application.js file. Here we will update the controller with the new isChecked property. Set it to true. This controller has only a Boolean property, isChecked. Open the application.hbs file. Here you can see the isChecked property is bound to the checkbox. After it's rendered, it should look as follows. Next, let's see how to use text areas. To create a text area element, we can use the text area helper. This wraps the Ember.TextArea view. We would create a new project as we created earlier. We will open the application.hbs file in the app/templates folder and edit it. Add a text area helper. In the browser, you can see the text area box will be displayed with 20 columns and 10 rows. It will look like this after being rendered. Adding actions and attributes work in the same way as the input and checkbox helpers. The input, text area, and checkbox are all helpers that make it easier to work with common form controls. They wrap around Ember.TextField, Ember.checkbox, and Ember.TextArea. With these helpers, we can easily bind elements and actions to them. Great! In this video, we covered how to use template input helpers. In the next video, we'll see how to use development helpers. In the previous video, we learned how to use template input helpers. We'll now see how to use development helpers. We'll first create an Ember application and a new component. Next, we'll add a new component to the application and render it. In the end, we'll add a debugger to allow the inspection of rendering context. Debugging your template is a task you'll often use. Here are the steps to do this. The most basic way of debugging Ember templates is to use log and debugger. First, we will create a new Ember application like we have created in earlier videos. Then we will create a new component called log-example, the same way we created earlier. Next, we need to run this command in the root application folder. This will create a new component template and JavaScript files. Open the log-example.js file in the app/components folder and add a new property called hello text. This is a simple component with just one property. Open the log-example.hbs file in the app templates components directory. Add log to it. This will display a string in the browser's console window. Now we can add this new component to our application.hbs file in the templates folder. Now we will render in terminal using the same command used earlier. After being rendered, the text hello text is hello world will be displayed in the console. We will now access the log-example.hbs in components folder. In this same example code, let's add debugger. Edit the log-example.hbs file and add it at the bottom. The debugger is the equivalent of JavaScript's debugger keyword. It will halt the execution of code and allow the inspection of the current rendering context. If we start the server and load the web page, the browser will halt on the debug statement while loading. At this point, we can open the browser's console window and use the get function to find the current value of hello text. The get command can retrieve any value from the context. In other words, it can retrieve any value from the component or controller. This works the same if the debug statement was in an each loop. You can get the context of the view as well in the console debugger. Now we will see what an Ember inspector is. The Ember Inspector is a plugin for Chrome and Firefox web browsers. It makes it easy to debug and understand your Ember application. When you're using the plugin, you'll see all sorts of information on your application, including routes, models, templates, controllers, and components. You can download it from the Firefox or Chrome plugin store for free. The handlebars library has made it easy to debug your templates. They're helpers that interact with the web browser to log information to the console or stop the execution of it. The Ember's debugger equivalent in JavaScript is the debugger. Both work very much in the same way. Awesome! So in this final video, we learned how to use development helpers. In this section, we started off by defining an application template. We then worked with conditionals in templates and displayed lists of items. Next, we learned about binding with element attributes and classes. We also learned how to work with HTML links inside templates and how to handle HTML actions. In the end, we learned how to use template input helpers and development helpers. In the next section, learn in depth about the Ember router.
Welcome to the section Ember Routers. Previously we saw Ember templates. In this section we will cover the following topics. First, we'll define an application route and set up a route model. Then we will handle dynamic segments inside routes and define them with templates. We will also redirect between routes, work with loading and error handling and query parameters. We will also work with asynchronous routing. This is the first video of the section, defining an application route. When loading your application, the router looks at the URL and matches it to the route. We'll go over some basics on how this works. First, we will add a new route to the route map. Then we'll visit nested routes and adding wildcards. Lastly, we will add dynamic segments to the application. Routers are an important part of Ember. They are used to relay information to the users and also for interlinking of templates using route handlers. The route map is used to define the URL mappings. Let's take a look at adding a new route using this .root. So we go to our terminal and open up the router.js file in the app folder. So this is the code for the router.js file. To begin, we'll create a route called about. Router.map handles the routing of the program. This route creates the about route. By default, the name of the route will be the same as the path to it. For example, the about route would be located at /about. We can specifically set the path using path. Instead of having all requests go to /about, let's change the path so they go to /me. So I will make the changes in path here. The new route about will be mapped to the URL about me now. To test this, we'll create a new template. So let's go to terminal and add a link to helper to our application route. First, we'll create the template. We need the following command. Let's run the command. The Ember CLI generated will create the template for us. This will create the about.hbs file in the app/templates folder in the application directory. So let's go there. We see the application.hbs file in apps/templates. Let's add the link to helper to it. The code creates a new link to the about template in the main application template. Now we open about.hbs and add a new message to the about template that we just created. This text will be displayed only when we navigate to this new route. We will now run the Ember server and open the browser. Note that the URL here is localhost 4200/aboutme. So here is our output. Run Ember server and click on the about template link. The about route will load and will look as follows. So what is application route? When your app first boots up, the application route is loaded, just like any other route. The application template will load by default. The application route is given for free and does not need to be added to the app/router.js file. The outlet will be used to render all other routes. It's a good idea to put the header, footer and other decorative content here. That was a single route. At times you may need multiple levels of routes. You may need templates within other templates. We do this with nested routes in our application. Let's say that we had about with a nested location and job route. So we go to our application directory in the app folder. There is a router.js file. This is the code. The router map has the highest level route called about. Underneath this route is the location and job. We need to create two templates needed for location and job. We will go to terminal and type three commands. Ember g template about/location. Ember g template about/job. Ember g template about. This will create the correct location.hbs and job.hbs in the app/templates/about folder, as well as the about.hbs file in the app templates folder. Let's check if the file is created in the application directory. Here, job.hbs and location.hbs. For us to be able to access nested routes, we need to edit the about.hbs and add outlet for the location and job nested routes. Here is the file. Note how the link to helpers route to about location. You can link nested routes with the dot notation. The location and job nested routes will render in outlet. Just to make things interesting, we'll update the job and location route templates. So we will go to app templates, about folder, and add in this line in location.hbs. And in job.hbs file, we will add this. Finally, we'll add a link to helper to the application route. the link to helper will route to about. This will be rendered in outlet. After running Ember Server, go to the browser and give the link as localhost:4200 about/location. Now you'll have access to click on the links and go between routes. If we click on a job link, the URL changes to http://localhost:4200 about/job. The outlet in the About template will then display the job template information. The third part of this video is adding a wildcard. You can use wildcards in your routes. This allows you to create URLs that match multiple segments. You might have seen the page not found message often. Let's create a wildcard for any URL that isn't found. For that, in a new project, update the router.js file in the app folder. The /* wildcard path will catch all the undefined routes and route them to page not found. Next, we create a new page not found template by adding this command. When we go to the app/template page, not found, we will see this message. The route will render in the application.hbs outlet whenever a user navigates to a URL that matches /* and no existing routes match. The last part is adding dynamic segments to our About application. One important responsibility of the route is to load a model. In this example, we'll create a simple dynamic segment in the router that lists multiple jobs for the About route. So in a new project, we will edit the router.js file and add the following code. View the output. We can see that the router map shows an About route and a nested location route below it. The location route is a dynamic segment that starts with : and is followed by an identifier. The :location_ID identifier will retrieve the model information from the location model. For example, if a user navigates to /about/5, the route will set the location_ID of 5, so that the location model with ID of 5 is loaded. We'll be going over the About routes in more detail in the next section. Index routes. At every level of nesting, including the application layer, Ember.js automatically creates a route called index. You don't need to map this in router.js. Similar to the application route, it's already there. The index route will automatically be rendered in the outlet of its parent's template. For example, if you created an index.hbs file in the app/templates folder, it would automatically be rendered in the application.hbs outlet. Keep this in mind when you create routes. Routes in Ember.js are defined in the app/router.js file. The router map is used to define each route and tells the Ember application what path should be used in the URL. By convention, each route has a corresponding template with the same name. Wildcards and dynamic segments can make routes more versatile so they can load specific data. Lots of things to remember, but we finally covered all the basics of routers. Great! In the next video, we'll learn how to set up a route model. Hi! Previously, we added a route-to-route model and worked with nested routes, wildcard and dynamic segments. In this video, we're going to set up a route model. Occasionally, you'll need to retrieve data from a model for a template. This route is responsible for loading the appropriate model. This video will go over how to do this. First, we need to create a new application. We have seen how to do that in the previous video. Then we open up the router.js file and add a new route. We'll call this route students. The students route will retrieve data from the students route handler. Next, we generate the students route by going to the terminal. We have to type the command ember g route students. This will create the students route, handler and template. We open the students.js file from the apps routes folder. We add a new model that returns a JavaScript object. The model hook normally returns an Ember Data record. However, it can also return any promise objects, plain JavaScript objects or arrays. Ember will wait till the data is loaded or the promise is resolved before rendering the template. For simplicity, in our example, we returned an array. After this, we'll create a simple each loop in the student.hbs file to display the data from model. The each loop will display each number in the array. The model data is returned from the route that we created earlier. Lastly, we run Ember Server and load the route at http://localhost:4200/students. It will look like this after it's rendered. Impressive. A very important job of a route is loading the model. Models are objects that represent data that your application may present to the user. The route can return an Ember Data record, object, or as in this case, an array. Thus, we have set up a route model successfully. In the next video, we'll see how to handle dynamic segments inside routes. In the previous video, we set up a route model. In this video, we're going to learn an important concept, dynamic segments. Using dynamic segments and dynamic models is an important aspect of routes. In this video, we're going to learn an important concept, dynamic segments. Using dynamic segments and dynamic models is an important aspect of routes. This video will go over how this can be accomplished. Before we begin our session, we'll need to set up a plugin called Ember CLI Mirage. Ember plugins are also known as add-ons. Make it easy to share common code between applications. The Ember CLI Mirage plugin makes it easy to create a mock server so that we can develop, test and prototype our data. We won't cover too much of this add-on in this chapter. For more information, you can download this link. We'll open a new project, run this installation command. This will install version 0.1.11 of Ember CLI Mirage, Bower and npm packages in the application. We'll be using this version for all the examples in this course. The installation will take time. Now let's go to the application directory. Open the config.js file. You can see it's a big file. We won't require all of this, but we do have to add a couple of new routes. The first fake route, students, will return all the student data from our Mirage in the memory database. The second fake route, /students/:id, will return only the data that matches the ID in the URL. This will be used later when we try out dynamic segments within our models. Now we will create a new set of fixture data for students. Create a new file called students.js in the app Mirage fixtures directory. This file name, students.js, matches the route, and it will be used to load the data in Mirages in the memory database. Be aware that Mirage also supports factories. Factories is an immensely powerful feature that makes it extremely easy to load lots of fake data. The factories can be used to test cases as well. For simplicity's sake, we'll just use fixture data. After that, we load a new scenario for our application. We need to open the default.js file to update it. This file is used to seed the database in development. The server.loadFixtures method loads all the fixture data so it can be accessible to the /students route. Now that our installation process is done, let's start with the task. Data in our model may never change. On the other hand, that data may change many times, depending on interactions with the user. This video will cover how to use dynamic segments within your routes and return data from the model. Let's begin by creating a new resource called students. Then generate an adapter named application and finally a route. So we go to our terminal and type these commands. This will generate the routes, adapter and template files needed for this video. Keep in mind that by generating the application route, you will be prompted to overwrite the application.hbs file. You can select N for no when this occurs. Now we update the router.js file in the app folder with a new dynamic segment route. The new route has a path of /students/:student_id. This route will extract student_id from the URL and pass it to the model hook as the first argument. For example, let's say we have a list of students and we want to be able to access each student's data by visiting student 1 and student 2. So here we will give the ID 1 or 2. Each URL would then return the data for that student. Then we update the application.js file in the app's adapters folder. This will create a new REST adapter that Ember will use for this example. This will be covered more in a later video. Next, we will edit the students.js file in the app models folder. This file is our model and will be used to retrieve data from the Mirage mock server that we created earlier. This code creates a new model with two attributes, name and age. The model file defines what the data will look like. We'll be covering this in more in a later section. For now, we'll be retrieving the data from the mock server. We will then update the students.js file in the app routes folder and add the Ember Data find record method. The model hook here has one argument, param. The param argument is student_id. That is passed from the routes URL. Ember Data has a find record method that takes two parameters. The first parameter is the name of the model and the second is the ID. This model will return the student record with the ID passed to it. We can now use this in our template. Next, we edit the student.hbs file in the app templates folder and add the model information. The model.name and model.age properties will retrieve the model information and pass to the template from the root. At this point, we should be able to run Ember Server and see the data when we access localhost 4200/student/1. To make things a little easier, we'll go ahead and create a new root handler for the main application root. To do that, we edit the application.js file in the app roots folder. Now, what are multiple models? At times, you may want to use multiple models on one root. This can be accomplished using ember.rsvp.hash. The hash takes parameters that return promises. When all the parameters are resolved, the Ember RSVP hash is resolved. In the model, it may look like this. Return Ember RSVP.hash students:this store find all student, books:this.store find all book. Each model is separated by a comma. This will allow our application to retrieve all the records from our student model. After this, we'll open the application.hbs file in the app templates folder. We'll add an each iterator that will link to each student's information. In this template, we are iterating through all the records in the student model. We are using each individual student's name as a link to our dynamic segment. The student ID argument is passed to the link to helper. When we run the Ember server, note the URL for the browser. You'll see a list of the students and a link to each student's information. After clicking on the student's name, the student.hbs template will load with the student's information. How does this really work though? Dynamic models allow data to change depending on the user action. This data will depend on the dynamic segment setup in the router.js file. The segment is defined in the router file and passed from the URL to the model hook as its first argument. Ember Data uses the find record method to find the correct record and return it to the template so it's available for use. So we use dynamic segments inside roots successfully. Wonderful! In the next video, we'll see how to define roots with templates. Hi, this is the fourth video of this section, defining roots with templates. In the previous video, we worked with dynamic segments and dynamic models in roots. In this video, we'll define roots with templates. Another job of the root handler is rendering the appropriate template, so this video deals with the same. In this video, we'll create a few nested roots and check where they get rendered. First, we create a new students and schools root. For that, we need to run these commands. This will create the nested students and schools root. In the application directory, we will add the project. Let's take a look at the router.js file. The generated command already created the roots that we need. The schools root has a nested root called students. By convention, the root will render the template with the same name. Therefore, the schools root will render to the schools.hbs file, while the students root will be rendered to the schools/students.hbs file. Now we will update the schools.hbs file in the app templates folder. The outlet will render the students.hbs file in the schools folder. Every template will be rendered to outlet of its parent root template. Next, we need to update the students.hbs file in the app templates schools folder. When we run the Ember server, we should see this result. Make sure that you visit the appropriate link. Here, both templates are displayed. The application outlet renders the school template. The schools template outlet renders the students template. If required, you can change where the root renders. Instead of rendering in the template with the same name, you can set it to anything using the render template method in the root handler. Go to app roots schools.js. So this is the code. The school root will now render to the another school template. Roots by default will render a template based on the same name as the root. Ember does this by convention. On the other hand, using render template in the root handler can change this default. This is all done under the hood by the Ember API. So we defined a router in template and got our desired output. Great! In the next video, we'll redirect roots. I'll see you there. Hi, this is the fifth video of the section, using redirection with roots. Previously, we saw how to define roots with templates. In this video, we're going to see how to redirect templates using roots using the transition to method. So let's begin. In our root handler, we have special hooks called before model and after model. We can use these hooks to perform actions before the model is loaded or after the model is loaded. The transition to method can be used to redirect the application to different routes. So we need to create a new application. Create a new students route. For that we run the command. This will generate the students route and template files. We'll go to app, routers and open the student.js file. For the sake of simplicity, we'll have the route handler return a simple array of numbers. First, we will add a standard mobile breakpoint that does not have a media query, following mobile first practices. The transition to method will redirect from one route to another. This option will redirect before the model is loaded, and transition to the teacher's route. We can also transition after the model is loaded using the after model hook. This will wait until the model is fully loaded before transitioning to the new route. You can check the loaded route before transitioning if needed. When transitioning to nested routes, it's a good idea to use the redirect model instead of the after model or before model hooks. This will prevent before model, after model and model from firing again after redirecting. Keep this in mind when dealing with transition to in nested routes. The after model and before model hooks occur after or before a model is loaded. The transition to method is used to redirect from one route to another. It can be used in the route handler or anywhere else in the application. In this video, we learnt redirecting of routers. Great! In the next video, we will work with asynchronous routing. Hi, this is the 6th video of the section, working with asynchronous routing. In the previous video, we learnt to use redirection with routers. A more advanced feature of the router is dealing with asynchronous logic. In this video, we will explain this concept using promises. In the root, Ember makes heavy use of promises. Promises are objects that represent an eventual value. We can use promises in our model. Let's create a new router for the application route. This is the command. If prompted to overwrite the template, type yes. This will generate the router file for the application default route. Then we add a new model to the application.js file in the app router folder. In the router, we created a new model. This model will be accessible to our application template. In this model, we are returning ember.vsb.promise, which is Ember's way of dealing with a promise. It can either resolve or reject. For the sake of simplicity, we are having it return a message. The setup controller hook to set up the controller for the current route. As we are overwriting the setup controller, it also overwrites its default behavior. Therefore, we must call super on it. Otherwise, it may affect how it normally behaves. We can use console log to output the model message to the console. Asynchronous routing. During a transition, the model hook is fired in the router. If during this transition the model is returning an array, it will return immediately. On the other hand, if the model is returning a promise, it must wait for this promise to fulfill or reject. The router will consider any object with a then method defined on it to be a promise. After the promise fulfills, the transition will continue from where it left off. It's possible to chain multiple promises, so the next promise on model must be fulfilled before the transition will be complete. Let's edit the application router one more time and set it to reject. In the previous code, the model returns a rejected promise. As described in the previous recipe, there is something called an error event. This will fire only when an error occurs in the model. We can then log the error to the console. We can test this by editing the application.hbs file in the app templates folder. If the promise doesn't reject, the model message will be displayed. If the model rejects, then nothing will be displayed. The route halts the loading and the console will show the message error. Error events bubble upwards. In this case, we are already on the application route and it can't bubble up any further. If we were in another route, we could have returned true and then that error would have bubbled up to the application error event. Then edit the application.js file again in the app root folder. Let's deal with the rejection. In the preceding code, the RSVP promise rejects. However, we then return the message anyway, by chaining another promise at the end. This way the transition won't halt and will continue. Then we run Ember Server and open a web page. You should see this message. Excellent. This message shows return from rejection because we handled the promise reject callback and returned a message anyway. Promises are a way for Ember to handle asynchronous logic. A promise is an object that represents an eventual value. The promise can either reject or fulfill, as in resolve a value. To retrieve the value or handle when it rejects, you can use the then method, which can accept two different callbacks. The first is for fulfillment and the second is for rejection. For example, you might use the rejection to retry or return different data. In this video, we handled asynchronous routing using promises. Great! In the next video, we'll understand loading and error handling. In the previous video, we worked with asynchronous routing. In this video, we will see loading and error handling. When routes are loading or there's an error, we have the ability to let the user know what's happening. This video will go over the basics on how to do this. First, we create a new project and the new students route with the help of this command. The Ember generate command will create all the necessary files for the students route. Next, we edit the students.js file in the app routes folder and add a new model to return. In our root file, we're returning an Ember RSVP promise. This promise resolves to a simple array that will be returned. Ember.run.later is a built-in Ember method that is part of the Ember run loop. It acts like the JavaScript's set timeout. In this case, we are setting the timeout for 2000 milliseconds so that we can simulate what might occur if the model was slow to load. After the 2 seconds pass, the resolve will return with the array. Then we add a loading substate template in the app templates folder. This substate will be loaded while the student's route is loading. A loading substate is created by adding a template with the name of the route and a dash loading at the end. For example, for the students route in our example, we called the students-loading.hbs substrate. The application loading the substrate would be an application loading.hbs. As an alternative to substates, we can use a loading event in the route. If the model, before model, model and after model hooks don't resolve immediately, the loading event will be fired. Add a new loading action that displays an alert box while the model loads and transitions to the application route. The alert box will fire while the route is loading. We will navigate to http://localhost:4200/students and you'll see the alert box while the model is loading. Let's start creating an error substate. Error substates occur whenever an error is encountered. It's very similar to the loading substate. Creating a new application, let's give the following command. This will create the necessary files for the teachers route. Then we edit the teachers.js file in the app routes folder and add a new ember.rsvp.promise with a reject. This will cause an error to occur. Create a new teachers-error.hbs file in the app templates folder. This will be displayed when an error occurs in the teachers route. Error substates like loading substates must be named after the route with a dash loading at the end. The template will be displayed during an error and doesn't need any other logic to occur. Alternatively, you can also use the error event in the route to display an error and redirect to a different route. Using the error event is just another way to handle errors. We could certainly have created the error route to transition too. The Ember route has built-in methods and events to handle errors and loading. When loading information, the model hook is waiting for the query to get completed. During this time, a template with a dash name loading at the end will be transitioned to immediately and synchronously. The URL will not be affected. After the query completes, the loading route will be exited, and the original route will continue. When dealing with errors, the error template will be loaded. Once again, the URL will not change to the error route. The error will be passed to the error state as its model. In this video, we got to know about loading and error handling. Excellent. In the next video, we will learn using query statements. Hello, welcome to the last video of the section, using query statements. In the previous video, we learned loading and error handling. In this video, we are going to take a look at query statements. Query parameters allow you to use the URL for the application state. In this video, we'll use query parameters in several different ways to show it works. Query parameters are optional key value pairs. They will create to the right of ? in a URL. Let's create a new project and generate a new application controller using the command Ember g controller application. The application controller will be generated in the app controllers folder. Next, we will update the application controller with a new query params for student in the app controllers folder. This will set up the binding between the student query parameter in the URL and the student property in the controller. If one changes, the other will change as well. If the student property was set to anything other than null, then the student property will have a default value. This is important to remember because query parameter values are cast to the same data type as the default value. In other words, if the student property was defaulted to the number 1 and you change the URL to student equals 2, then the property would be set to number 2, not the string 2. Additionally, remember that default values will not be serialized in the URL. Update the application.hbs file in the app templates folder. we'll add the student property to test. This is a very simple template that just displays the student information from the controller. We then start Ember Server and try changing the URL. Navigate to this link. The template will be updated in order to display the new student information, so you can see the student name. Everything to the right of the question mark in the URL can be used in this query parameter. Each parameter is separated by an ampersand. In this case, the student property is set to Eric. This will be updated in the template. Next, we'll add a link to helper with a query parameter. It's important to realize that we can pass query parameters using the link to helper. Then we create a new application.js in the new project using the command. This will generate the application controller that we can use for our query. Now we edit the application controller and add a new query parameter. In this example, we created a simple query parameter called student. Next, we'll update the student application.hbs file in the app templates folder, add the student property and the new link to helper with a query parameter. You can add a query parameter link to by surrounding it with parentheses and using the subquery params sub-expression helper. After the sub-expression comes the key value pair. In this case, we have a student key. Lastly, start the Ember server and click on Jane query link. This page should appear. Let's see how we will use transition to with a query parameter. Query parameters can be used when transitioning routes with the transition to method. You can add the query parameter as the final statement with the object key query params. For example, if you need to transition to the application route and you need to pass the query parameter for student, it might look like this. Now we move on to resetting a controller's query parameters. By default, query parameters are sticky. In other words, they are preserved when you move in and out of the route. They will also preserve the model loaded in the route. You can override this behavior in a couple of ways. One is to pass the default query parameter to the link to helper or use transition to. The other way is to use the route reset controller hook. Let's create a new project and generate a new route called route1 using these commands. This will create a new route and controller for route1. Then we edit the route1.js file in the app controllers folder. Just like our previous example, we are using a simple query parameter called student. After this, we edit the route1.js file in the app routes folder and add a new reset controller hook to the route. In this route, we are using the reset controller hook. This will fire whenever someone exits or transitions from the route. As before, we must call super so that we don't prevent the default behavior. The isExiting argument will be false only if the route's model is changing, otherwise it will fire. The controller.set method is a way in which we can access the student property. We'll set it to null so that when we move away from route 1, it will not be preserved. Next, we will edit the application.hbs file in the app templates folder. Add a link to helper to the new route1 route. This template is very simple. All we are doing is creating a link to the new route1. Then we edit the route1.hbs file in the app templates folder. Add the student property and a link back to the main application route. This template displays the student property that we can set via query parameters. It then has a link back to the main application route. At last, we run the Ember server and load the application. Enter the URL http://localhost 4200/route1 query student equals Eric. This will display route1 with the query parameter for the student. If you click on the app link, it will bring you back to the main application. If you click on the route1 link again, it will not preserve the query parameter and will be reset. It will look like the following image. Query parameters help define an additional application state by serializing data in the URL. They are set in the route-driven controllers. We can use transition to and link to helpers to navigate to them easily. Well, that's about it for this video. We saw how to use query parameters. This brings us to the end of the section. First, we defined an application route and set up a route model. Then we handled dynamic segments inside routes and defined them with templates. We also redirected between routes and worked with asynchronous routing. We also worked with loading and error handling and then query parameters. In the next section, we'll look at Ember controllers.
Hi, welcome to the 5th section of the course. In the last section, we saw Ember Router. Controllers in Ember.js are similar to components. They can encapsulate code, handle actions, and have properties. In addition, controllers can transition to different parts of the application and retrieve information from other controllers. In the near future, controllers will be completely replaced by components. However, until this happens, it's good to have some basic understanding on how controllers work. This section helps us with that. In this section, we will learn how to store application properties and deal with handling actions in controllers. We will work with transitions and finally manage dependencies between controllers. Here is the first video of this section. In this video, we see how to store our properties, update the application controller, and also how to update template to display the properties. One advantage of a controller is storing properties. Controllers have properties that are stored in the application, which is unlike the model where properties are saved to the server. In this video, we'll take a look at a few different types of properties and how they can be displayed in a template. In a new application, run this command. In this application, we'll be using the application controller to store all our properties. Let's go to our application directory now. Open the application.js file in the controllers folder. Update the application controller to add a new action and a few properties. This controller has two properties. The first property contains a string. The second has a Boolean value of true attached to it. The enter action displays a few alert boxes. Let's take a closer look at the enter action. When accessing properties in Ember, always use this get and this set. This guarantees that the property will be read or set correctly in Ember. In addition, we can use this get properties. This allows us to get multiple properties at once. It returns an object of those properties and their values. Another useful method is the toggle property. This will take a Boolean value and toggle it. In other words, a value of false will become true and vice versa. Be aware that you don't have to declare each property in the controller definition. Properties can be retrieved directly from the template and be manipulated. In the code example, the prop1 property is received from the template. It was never defined in the controller. If needed, you can set default property values. Next, we will open the application.hbs file in the templates folder. Update the template for the application. Display the properties. As you can see here, the prop1 property is bound to the bracket input and input helper. By default, bracket input tags are one way. What this means is the prop1 property is retrieved from the controller when the template is rendered. It's copied over, and the changes to the property are not reflected back in the controller. On the other hand, input helpers are bound two-way. Any changes to the value in the input helper will be reflected in the controller. Start the Ember server and update the values in the one-way input. You can see that even though the bracket input tag value is set to prop1, it's not changing the prop1 property elsewhere in the template. This is because the value is set to work only one way. The only way to change the value of prop1 in the controller is to send it as an action back to the controller from the template. This is the basis behind data down, actions up. Data is copied down to the template from the controller or component. Any changes to it are then sent back in an action to the parent component or controller. Keep this concept in mind as it's becoming more and more popular in Ember. Next, we update the values in the two-way input helper box. The two-way input helper updates all the values in the template because it's linked back to the controller. Any changes to the property in the template are reflected back in the controller as shown here because it's two-way bound. Press the value of prop1 button. When the button is clicked, an action is triggered. It displays three alert boxes. Each alert box will display the prop1 property. It will then toggle the third Boolean property from true to false. Computed properties or observers can be added to controllers as well. To learn more about these, check out previous videos in the section, the Ember.object model. Controllers can use properties to show information to a user. Unlike models, they are not persisted to a server. However, they are persisted in the application state. When working with templates, they can be one-way or two-way bound. Nice! So now we know how to store application properties. In the next video, we'll deal with handling actions in controllers. In the previous video, we learned how to store application templates. In this video, we'll see how to handle actions in controllers. We will start this video by updating the application controller and add actions to it. Next, we will update the application root and add new actions to it. In the end, we will add buttons to the application template. Let's get started with this new video. This video is about how to handle actions in controllers. Actions are important to controllers. They are triggered by the user action and can be used to change the application state. In this video, we'll create 4 different types of actions and see how they react to different situations. Create a new application as earlier. In a new application, generate these files using the commands. We'll be using the controller and application to store actions. Some actions will bubble up to the root and some won't. Open the application.js file in the controllers folder. This is the code. Update the application controller and add 3 new actions as shown. Let's take a look at each action. This is a normal action. It just displays an alert box. This action is a little more interesting. By default, all controller actions return false if they exist in the controller. By returning the value to true, this action will bubble up to the application root after the alert box is displayed. The root can then handle the action. The action has a value passed to it. It will display this value to the user in an alert box. The text in the alert box is using something called ES6 template strings. This makes it a little easier to display variables in text. Let's open the application.js file in root folder. Update the application root with 2 more actions as shown. Each action displays an alert box. You might have noticed that the enter action was not present in the controller. By convention, template actions will look first in the controller. If the action is not defined in the controller, it will bubble up to the root. Next, we need to add 4 buttons to the application template. Each button has an action bound to it. By default, this is bound to the click event. This can be changed if needed. Now, open the terminal and run Ember Server. Next, open a web browser to see the following screen. Each button represents a different type of action. Click on the first button. This displays a message from the controller. Click on the second button. It will display a similar message. The alert box is displayed first from the controller. This second alert box is displayed from the application root. Click on the third action. This shows the message from the controller with the value passed. Click on the last button. This will show the message from the application root as it was not defined in the controller. Actions in Ember bubble up, but they are not dependent on the user action. They start in the controller and then move to the root. We can add actions to our templates and pass values from the template to our actions. Awesome! So now we know how to handle actions in controllers. In the next video, we'll see how to work with transitions. In the previous video, we learned how to handle actions in controllers. In this video, we'll see how to work with transitions. In this video, we will add new roots and then add action to the controllers and update the template. We will end the video by adding a link to both the roots. When inside a root, you can add the controller to transition to another root. We'll look at an example on how to transition from one root to another. Create a new application as we have in the earlier videos. In the application, generate these files. These commands will generate 2 different roots for us, the foo1 and foo2 roots. Each root will have a button that transitions to the other root. Each controller will handle the action logic. Now let's open the foo1.js file in the app directory and add an action to the foo1 controller as shown here. This controller has one action called enter that transitions to the root called foo2. The this.transitionToRoot method is used to transition different roots in the application. It takes 2 arguments. The first argument is the name of the root. The second argument is optional, and it is where you enter in the model. By default, it will be serialized in the URL if added. The transitionToRoot method can take paths as well. For example, you might have a foo2 nested root called foo3. You can transition to this root by calling this.transitionToRoot foo2.foo3. Next, we need to open up the foo2.js file in the app folder. Add an action to the foo2 controller. When the enter action is triggered, it transitions to the foo1 route. Open the foo1.hbs file and update the foo1 template as shown here. This button triggers the enter action in the foo2 controller. Let's open the index.hbs file in templates folder and add a link to both the routes in the index template file. This uses the link to helper in a non-block form. The first argument is the name displayed and the second is the name of the route. Next, you need to open the application.hbs file in the templates folder and update the application template file as shown. The application template file has a link back to the application at the top. Go to the terminal and run Ember server command. You'll see the following screen after opening a web browser: http://localhost:4200. This displays a link to each route. Click on the foo1 route link. The following page will be displayed. This displays the foo1 route. Click on the foo2 route button. The following screen will be displayed. After the button is clicked, the foo2 route is displayed. To navigate through an appliance, we can use transitions inside a controller. The transition to route method is used to transition from one route to another. It's part of the Ember.controller class. Excellent! We just saw how to work with transitions. In the next one, we'll see how to manage dependencies between controllers. Previously, we learned how to work with transitions. In this video, we're going to take a look at how to manage dependencies between controllers. We will start with generating new routes and templates and verify them. We will then add a new model to the route. In the end, we'll add and create properties in the controller. Often, controllers will need to access other controllers' properties and models. This is especially important when you have nested resources. In this video, we'll take a look at a nested controller that needs access to the parent controller's model and properties. Create a new application. Next, we'll generate a couple of new routes and templates by using this command. These commands will generate the foo1 and foo2 routes and controllers. The foo2 route is a nested route. The index template will contain links. Now let's go to router.js file in the app folder. Verify in the router.js file that all the routes have been created correctly. As we generated the routes, router.js should already be set up for us. As you can see, the foo2 route is nested under the foo1 route. What this means is that we'll have access to the URL at /foo1/foo2 to access the foo2 route. Next, we'll open our foo1.js file in the routes folder. Add a new model to the foo1 route using this command. All this route does is return a model with a simple array of letters. Open the foo2.js file in the foo1 folder. Add a new model to the foo2 route using this code. The nested foo2 route also returns a simple array of letters in its model hook. You can now add a property to the foo1 controller file in the controllers folder. This controller has one string property. Let's create a property in the foo2 controller that can access the foo1 model and properties. Open foo2.js file in the foo1 folder. Here is the code. Ember inject controller allows us access to the foo1 controller and properties. We can then use the ember.computed.reads method to set the foo1 property. This creates a read-only computed property that we can use in the template. We now need to update the foo1 template file. Open the foo1.hbs file in the templates folder. You can see the code here. All the foo1 template does is display the list from the model. Next, we need to update the foo2 template file. For that, you can open the foo2.hbs file in the foo1 folder. You can see the code here. The foo2 template has access to all the properties of the foo2 and foo1 controllers. In this example, we can use the each helper to list all the letters in the foo2 model. It can also use the foo1 computed property to list all the letters in the foo1 controller. We can even access individual properties using foo1 controller. Now let's open the application.hbs file in the app folder. Add some basic links to the application and index template files. Here you can see the code for it. The application file will have a link at the top as shown here. The link to helpers here link to the foo1 and foo2 routes. Start the Ember server and run it like we have done before. You'll see the following screen after you open a web browser and enter the link http://localhost:4200. The index home screen displays a link to each route. When we click on the foo2 route, the following window will be displayed. As you can see, the foo1 template is displayed as well as the foo2 template. The foo2 template has access to both the foo2 and foo1 properties and model. Controllers can access other controllers using Ember.inject.controller. This is known as a dependency injection. Dependency injection occurs when we take one object and inject it into another. Dependency injection is covered in more detail in Section 11, Real-Time Web Applications. Great, that's about it for this video. We now know about managing dependencies between controllers. This also ends Section 5. Here we started off with storing application properties. Then we handled actions in controllers. We then worked with transitions. Finally, we managed dependencies between controllers. In the next section, we'll see how to work with Ember components. Hi, in the previous section, we saw Ember controllers. Welcome to Section 6, Ember components. Components are a major feature of Ember.js. With components, you can encapsulate code and create widgets and custom tags. In this section, we'll see how to use components in an application, handle events and actions, pass properties to a component, and wrap content inside of it using yield. This is the first video of the section, using components in an application. In this video, we'll see how to create a component and add it to a template. To begin with, we'll create a simple component that displays student information. In a new application, we have to generate a new component. As I already created a component, I don't need to do that again, but I will tell you the command. Ember g component student-info. All components must have a dash in their names. This will generate the student-info.js component in app components folder, and also in app templates components below as student-info.hbs. Now we have to edit the student-info.js file. We add a few simple properties here. We have added 3 properties, name, grade, and nickname. We'll use these later on in our template. Then we update the component student-info.hbs template in the app templates components folder. In this template, we are simply displaying information from the component, so here is the code for that. Finally, let's edit the application.hbs file in the app templates folder. The component is added to the application template by adding the handlebars expression student-info to it. This will register an inline handlebars helper automatically and render the contents of the student-info.hbs file to the application.hbs file. Then we will edit the student-info.hbs file and add yield to it. The yield expression will be the placeholder where the outside template will render when the component is in block form. We'll discuss this in a later video. Next, update the application.hbs file with the new block form component. The component has a hash in front of the name. This is a signal to the handlebars templating engine that the component will be in block form. The yield helper in the student-info.hbs file will display the contents in the block. Now we will run the Ember server. So I'll open the terminal window, type the command Ember server. You can see that the server is being connected. Now we will open our browser and navigate to localhost :4200. We see the information of the student. All components are div tags. In other words, all components that are created by default will be rendered in a div tag. This can be changed using the tagline property. You simply need to add this property to the JavaScript file in the components directory. Let's take a look at an example of doing this with the student component that we created in the earlier section. In a new project, create the student-info component. For that, we need to run the command ember g component student-info. Now I will edit the student-info.js file and add this information. This component has the same properties as before. Update the student-info.hbs with this information. Following that, we create a new application route in the app routes folder. and add a new model method called comp::application.js file. This model sends back a string array. This array will be used in our template as the name of the component that we want to display dynamically. This is the last step. We update the application.hbs file in the app templates folder and add a new each helper that will display the new dynamic component. To display a dynamic component, you must use the component helper. The first argument of the helper is the name of the component that you want to use. In this case, comp is rendered to student-info. Note that we can use the component helper in line or in block form. If the component is rendered in line, yield is not used. Finally, we run the Ember server and open our browser. Here is the output we get. Components are used to encapsulate data into a form that can be easily reused throughout an application. Each component can be in block or inline form and is rendered as a div tag by default. Components have a template and JavaScript file. Okay, that was a big video. We successfully used components in an application. Excellent. In the next video, we'll see how to use events in our created components. Hi everyone, welcome to the second video of this section, using events in components. In the previous video, we created a component and added it to the template. In this video, we'll go a step further and add events to them. To do this, first we need to create a component, add application, and add an event. Let's take a look at an example that will make you understand. We'll generate a new component called student-info. Let's go to our terminal. This is my project. We will generate a new component called student-info. This will generate a component file in the components folder and the templates component folder. Now let's go to our application. You can see the app components student-info.js file. We need to add a new click event, which I have already added here. So this is my student-info.js file. The first thing that you'll notice in this example is that we are using the ES 2015 destructuring assignment. The destructuring assignment syntax extracts data from arrays and objects. Instead of typing Ember $$ everywhere, I can just type $. Ember CLI by default has jQuery installed. We're using the jQuery syntax to fade the HTML document and fade it back after the component is clicked. We aren't limited to just the click event though. There are several events that are available to Ember. First is touch events. We have touch start, touch move, touch end, touch cancel. In keyboard events, key down, key up, key press. In mouse events, mouse down, mouse up, context menu, click, double click, mouse move, focus in, focus out, mouse enter, and mouse leave. In form events, submit, change, focus in, focus out, input. In HTML5, drag and drop events, drag start, drag enter, drag leave, drag over, drag end, and drop. For the last step, we need to add the component to our application template. Open the application.hbs file. There is no need to edit the component template. For now, we'll just set the component to be in block form so that any click on the element will trigger the event. So this is the code for the application.hbs file. Here, the student-info component is in block form. Click anywhere in the block to trigger the click event and cause the HTML document to fade. There is an index.html file in the root of the app folder. This file has the default HTML and head tags. It also contains some links to your CSS and vendor files. You may notice that there are content for helpers. These are used with Ember add-ons and should not be deleted. Now we will run our Ember server, and the template should render this. The HTML document will fade if any part of the student info block is clicked. Splendid! Well, how does it work? Ember events in components work by adding the name of the event as a method in the component. These events are fired in the template that the component has been added to. Components by default are div tags, so any event that occurs must occur in the contents of the div tag in the template that is rendered. Ember supports several different types of events. Custom events can be registered using the ember.application.customEvents method. To sum it up, we've successfully used events in components. In the next video, we'll see how components communicate with the help of actions. I'll see you there. This is the third video in the section Implementing Action in Components. In the previous video, we used events in our components. In this video, we're going to implement actions in components and learn about closure actions. Actions can be sent back to the parent or be handled in the component. Actions can be added to different HTML tags and be handled within components. Let's take a look at a few steps that show this. First, we'll create a student list. For that, we go to Terminal and type in the following command. This will generate the necessary student-list component and the necessary files. Now we go to the application directory and update the student-list.js file in the app components folder. We'll need to create a few actions and a new array. The first part of this component is the init method. This will fire as soon as the component is initialized. This is a private method that sets up the component. As we are overriding this framework method, we must call super so that the component is created correctly. We then call the setup method. The setup method creates a new list of students array, clears it, and creates 3 new string objects by popping them onto the array. As we are creating the list of students array in the init method, it will be local to this component instance. It's good practice to declare objects or properties in the init or did_insert_element methods. We'll be discussing did_insert_element hook later in the video. You can see that there are 2 actions listed, remove and reset. The remove action removes or pops off one object from the top of the array. The reset method calls setup, and this returns the components to its original state. After finishing this, we'll open the student-list.hbs file from the apps templates components folder. We have to add a couple of buttons and use the each helper to list the contents of the array. The action helper will fire when the remove and reset buttons are pressed. The first argument to the action helper is always the action name. The each helper lists the contents of the list of students Ember array. Lastly, we add the student-list component to the application template, apps/templates/components. This will display the contents of the student list component. Finally, we run the Ember server and we view the output in our browser. Now let's see what happens when we click on the remove and reset buttons. As visible, pressing the remove button is removing each item one by one. The reset button will reset the array back. Great! Now we will move to the second part of our video, closure actions. Closure actions are used to send actions from a parent to child component. They make the passing of actions much easier. This helps to separate logic between different parent routes, controllers and components. So let's go to the terminal again and generate a new application route and a student-list component. We have to type the following commands and run them. This will generate the application.js file in the app routes folder, the application controller and the student-list component. In the app routes folder, open application.js file and add a new list of students array. So this is our array. The before model hook will run before the model is set up. In this before model, the reset method is called. This adds the default data to the array. The model hook returns the list of students array. In addition, we also added 2 actions, remove and reset. This was the same code that we had in the component earlier, but we moved it to the root instead. Now we edit the application.hbs file and add the component that we just created. This template will show a list of students from our model and our student list component. The onRemove and onReset properties are set to actions that are basically functions in our parent controller that we can pass to the component. This is called a closure action. All closure actions must have parentheses surrounding the action remove controller action. Next, we will open the application.js file in the app controllers and add 2 new actions to the controller, remove controller and reset controller. These 2 actions use this send to send the action to the remove route and reset route actions that we defined earlier. You can use the send method to trigger actions from parent routes or controllers. Next, we update the component template file. This component displays 2 buttons that are linked to actions that are defined in the component. Update the component student-list JavaScript file with the 2 new actions. These actions will be triggered from the component template. At this point, they'll trigger the function that was passed to it from the closure actions, onRemove and onReset. To invoke these methods, you can do it using either this.get or this.attrs. The this.get method and the name of the property, in this case onRemove, will invoke the method passed to it. In the other case, you can use this .attrs to access the attributes on the property to invoke the function that was passed on, this .attrs.onReset. The action will flow this way: application template to component to controller to root. The end result is the root triggering the action to remove or reset the list. As the component is now added, we run Ember Server and see our list. We can now remove or reset it. Clicking on the Remove or Reset buttons will trigger an action that was passed in from the controller. This action will bubble up to the root to reset or remove an item from the list. Actions can be handled in a few ways in a component. Actions can be added to different HTML tags and be handled within components. Actions can also be sent to parent components or controllers using closure actions or send. Closure actions make the passing of actions much easier. We can pass down actions to components that they can invoke. This helps separate logic between different parent roots, controllers, and components. So that's about it for this video. We learnt about actions in components, passed actions between components and understood closure actions. Good! In the next video, we will learn how to pass properties and using yield to a component. This is the last video of the Ember Components section, passing properties and using yield with components. In the previous video, we implemented actions in the components. In this video, we'll create a student list. However, we will pass data to the component using properties. Then we'll look at an example of using yield to show information in a template. Components are isolated sets of code that do not have access to the outside world, so any data that components need must be passed to it. You can set this up by adding properties after the name of the component in the handlebars expression. First, we create a student list component and application root. You must have gotten the hang of this by now. This will generate the application.js file in the roots folder and the files necessary from the student-list component. Then we edit the application.js file in the app/roots folder. So you see, this is my code. This model will return a simple array of 3 names. Next, we will open up app templates components folder. So this is my student-list.hbs file. This will take the comp model property and iterate over it using the each helper. Let's open the application.hbs file in the app templates folder and add the new student-info component. The student-list template has the comp model property. This property passes in the model, that is the application model that we set up earlier in the root. Keep in mind that comp model is accessed from the inside of the component. The model is accessed from outside the component. The component does not have any access to the model unless it's passed to it. Finally, we run Ember Server and see a list of elements, in this case names, in the model. So we got the desired output. Perfect. Next, let's start with using yield with components. We know that components can be set up in block or inline form. When in block form, components can yield information. We'll open a new project. Here I have given the path for my project folder. Now I will type the command for creating student component. This will create the student component. In the application directory, after this we will edit the student-info template file and add some text. The yield handlebars expression works by taking the information in the component block and rendering it. Next, we add the new student-info component to the application template file in apps template. When in block form, designated by the hash sign, the information in the block will show up in yield. Inline components do not have the hash and do not yield information. Now we will run our Ember Server. After running Ember Server, the following screen will be displayed. As you can see, the component yield template displays the information in the block. So let's see what we learnt. We first passed data to the components using properties. After that, we passed information block using the yield handlebars in a component. Great! Let's have a quick recap of the entire section. First, we had an introduction to components and learned how to use them in an application. Then we used events in components. Following that, we implemented actions in components and understood that it is their way of communication. We also learned to pass data components using properties. And last but not least, using yield to display information blocks in components. In the next section, we will see various Ember models and work with data in Ember. Hi, welcome to the 7th section of the course. The previous section took us through Ember components. This section explains how to manipulate records and customize adapters. In this section, we will first understand the functionalities of Ember Data. We will then see how to create, read, update and delete records with Ember Data. Further, we will see how to use fixtures and customize the adapter and serializer. Towards the end of this section, we will see how to work with relationships. Here is the first video of this section. In this video, we will see the functionalities of Ember Data. We see how to use Ember Data to store, update and retrieve data from a server. Later, we'll see how to use REST adapter to pass, store and display data. Cool, let's get started then. Ember Data uses a single data store that can be accessed through an application. In this example code, we'll create a simple application that retrieves a list of books and displays it to the user. Before we begin, we'll need to mock data for our server. Ember CLI has a built-in mock server that can handle the situation by generating a basic express server. However, for the purposes of this recipe, we'll go ahead and use the Ember CLI Mirage add-on. It has more features and is easier to use. You can find more information about Ember CLI Mirage at this GitHub link. To begin, let's create a new application by running the command. After the application has been created, let's install the add-on to it. For that, we need to run the command. This command will install the latest Bower and NPM packages needed, and create the book factory for Mirage. To make this video work, we'll need to mock book data. Edit the config.js file in the app/mirage folder. Here's the code for it. The configuration file will set the fake roots that we need for our data. The /books root will return all the books data, and the /books/:id root will return individual books based on the ID passed in the URL. Next, we need to update the book.js file in the app/mirage/factories folder. Add the following properties as shown here. This file sets the properties that we'll use later for our model. The title property refers to the name of the book, author refers to the person who wrote the book, and the year is the year it was published. To make things a little easier, Ember CLI Mirage includes a library called Faker. This library generates data that we can use to populate our in-memory data store. Now we will update the default.js file in the app/mirage/scenarios folder. Make sure to delete the comments around the server. This scenario will generate 10 new book records every time the browser is loaded. After the browser is loaded, the books will be generated via the factory. Let's go to our terminal now. We'll begin by creating a model file for our books, a REST adapter and a root. This command will generate a new model called book and set the title, author and year as properties in this model. The generate adapter command will create a new adapter for our application, while the last commands will generate roots for the book and the application. Open the book.js file in the app/models folder. It should look as follows. The models file is a representation of the data that we'll be using. We can use 3 different types of data: string, number, or date. The data will be loaded from our mock server. Next, we'll open the application.js file, which will be created in the app/adapters folder. Ember Data has several adapters available for it. One of the easiest to use is the REST adapter. The REST adapter data expects the data from the server in this format. We'll need to be able to retrieve data from our data store and present it to the user. Edit the application.js file in the app/roots folder. Add a new model that returns all the books listed. As discussed in section 4, Ember Router, one of the responsibilities of the root is returning the model data. The Ember Data Store has a method called findAll that will return all the data from the book model. By convention, the Ember application will execute an HTTP GET to the /book/URL and expect a JSON payload in response. As this model is in the application root, it can be accessed in any template. Now we will update the application.hbs file in the template folder, as you can see here. Next, we will display the new data from the mock server. This template uses the each helper to iterate through all the data that is returned from the model hook after the page loads. The link to helper will pass book.id in the URL as an argument. We'll use the book title as the link. Let's open the book.js file in the roots folder and update the books root so that it returns a single record. The model hook receives a parameter from the URL. The find record Ember data can be used to find individual records. It will make an HTTP GET request to the /books/:id URL when the model hook is loaded. The first argument is the data store and the second is the record ID. Now update the router.js file in the app folder with a new dynamic root for books. This new root for books has a path of /books/:book_id. To access the books root, you have to submit an ID in the path. We will now update the book.hbs template. Accessing this root will trigger the model hook. This will render author and year of the book selected. Now we will go to our terminal and run Ember Server and open a web browser. You'll see a list of all the titles with links to each individual book. Each post has a unique ID. Clicking on a link will display the title and author of that book. Models represent data in Ember. These models can use Ember Data to store, update and retrieve data from a server. The data from the server is usually sent in the JSON format. Ember offers a handful of adapters to the interface with the data coming from the server. The REST adapter is the most commonly used. It expects data in a certain format so that Ember can pass, store and display it to the user. Ember Data caches the data after it retrieves the data from the server. This minimizes the amount of round trips to the server. However, Ember Data will make a request in the background whenever a cached record is returned from the store. If the data has changed, it will be re-rendered on the screen. Nice! So now we know the functionalities of Ember Data. In the next video, we'll deal with creating, reading, updating and deleting records with Ember Data. In the previous video, we understood the functionalities of Ember Data. In this video, we will see how to create, read, update and delete records with Ember Data. We will start this video by retrieving data from a back-end server with the help of adapters. Later, we will make requests to a back-end server. In the end, we will find, delete and save records. In the previous video, we retrieved already existing book data from our mock server and displayed it to the user. Ember Data also has the ability to create, delete and even update records from the data store. We'll be looking at these methods and more. Just like the previous example code, we'll need to install Ember CLI Mirage. Take a look at the previous video for instructions on this process. We'll be using the same factories as the book recipe, and we'll be adding new methods to add, edit and delete data. In the Mirage folder, open the config.js file. This will mock our backend, allow us to create, update and delete data. This is done using the HTTP put, post and delete requests. We'll use these later in our program. Update the book.js file in the app/mirage folder. This factory will be used to generate fake data that the Mirage in-memory database will return. Update the default.js file in the scenarios folder. Every time that an application loads, the server will create 10 book objects. For this video, we'll be adding to the book example that we had in the Understanding the Functionalities of Ember Data video. Create a root called new and a controller named books. This will generate the new root and books controller files. The new root will be used to add a new book to the repository. In this template, the input helper is used to create 3 text boxes. Each will be bound to the info property. A button at the bottom will submit the changes to the new text action method. The cancel button will trigger the cancel action. Update the new.js controller with the new actions for cancel and new text. There is a lot going on here. Let's take a look at the new text action first. In this action, we are getting the info property that was declared earlier. This property is an object that is used to store values from the template. The store has a method called createRecord that takes two arguments. The first argument is the model. The second is the object that we want to store. In this case, we want to add a new book record to the store. We use the inf object to set the title, author, and year. Using the createRecord method doesn't persist the changes. The save method is used to persist data back to the server. The save method is a promise. It will either succeed or fail. If it succeeds, we use the transition to root method to change the root back to the main application. Afterwards, we set the info property back to an empty object. We do this so that the template input helper is cleared of all data. If it doesn't succeed, then we output an error to the console. The cancel action returns true. What this means is that instead of the controller handling it, it will be bubbled up to be handled by the root. Now we will take a look at REST with Ember. When using the REST adapter in Ember, the save method will send a put, delete, get or post HTTP request to the server. The put request will be sent during an update. The delete request used to delete a record, post is used to add a new record, and the get request is used to retrieve records. This is done by convention by the Ember REST adapter. Update the books.hbs template file with a new action to update. We've updated the books template to behave differently from our last example. In this example, it will allow us to edit the entries as follows. Update the books.js controller to handle the new update text and cancel actions. The update text action gets the current book model, sets the year, and then saves it. Afterwards, it transitions to the application route. If needed, we can handle the error condition if the save promise fails. For the sake of simplicity, we'll leave it as is. The cancel action returns true, which means that it will bubble up to the books route to be handled. Update the books.js file in the root. The root file is the same as the previous recipe, except now that we have a cancel action. The cancel action will be triggered after the controller returns true. By returning true here, the action bubbles up one more time to the application route. Update the new.js root file. This file will receive the action from the new controller. It also returns true, which means that the cancel action will be handled by the application route as well. Update the application root file. The cancel action in the application route handles the new and book routes cancel action. In either case, it will transition to the application route. In summary, the bubbling of the action went from the new controller to the new route and finally to the application route. If the cancel action was not included in the controller, by convention, the action will automatically bubble up. We need to update the application template and add a new option to delete records. Update the application.hbs file with the new delete action. The application will display each book. There is also a delete action button at the bottom of each record that passes in the book record. Update the application controller to handle the new delete action. The book record has a method called deleteRecord. This deletes the record. However, it doesn't send the HTTP delete request to the server until save is done. Another method called destroyRecord will delete and save at the same time. For this example, we'll use the delete record instead. Load the Ember server and you'll see a list of records. You can click on each record and delete or edit it. If you're not using Ember Data, here's an important note for you. Ember Data is the preferred method when working with a back-end data store. However, it doesn't have to be the only option. When defining model information in a root, you can use Ajax method or define your own repositories as well. You can use services and inject them throughout your application if needed. This will take a substantial amount of extra work depending on your setup, but is an option. Ember Data comes with several adapters that can be used to retrieve data from a back-end server. The REST adapter allows the user to make requests to a back-end server using HTTP GET, delete, put, and post requests. By default, it expects responses in JSON. The Ember Data store methods allow a user to find, delete, and save records. The Ember save method triggers a response to the server. Before the save is done, records can be rolled back if needed. Awesome! So now we know how to perform CRUD operations with Ember Data. In the next video, we'll see how to work with fixtures. In the previous video, we learned how to create, update and delete records with Ember Data. In this video, we'll see how to use fixtures. We will first generate the model and routes for the application and later see how to use fixtures data. In the end, we'll see how to use the each helper to iterate through all the records. Fixtures are another way of mocking data. It's static data that can be used in our model to display to the user when testing our application. In this video, we'll see some basics on how to set it up with Ember CLI Mirage. As with many other examples, we'll be using Ember CLI Mirage. Instead of using a factory, we'll set up fixture data. We'll begin by creating a new application as we have done earlier. Then add the Ember CLI Mirage add-on and generate the model and routes for the application. So here we are in the application folder, book example. Here we need to run these commands. These commands will generate the basic structure of our app. In this application, fixture data will be used to display student information. For the sake of simplicity, we'll only be displaying this information and not manipulating it. Let's go to our directory now. In the Mirage Fixtures folder, update the students.js file and add the fixture data. The fixture data here has 4 records. Each record has a different student's name and age. To use fixture data with Ember CLI Mirage, you must enter it as an array of objects. We'll now update the config.js file in our Mirage folder. This file is used to set the student's route. This data will set up a mock server endpoint for Ember Data to reach. By convention, Ember Data will look for the URL path of the pluralized model name. In this example, our model will be student. Therefore, when Ember Data looks for data, it will do a GET request to /students on the server as shown. Now we will add a new scenario to the default.js file placed in the scenarios folder for the fixture data. The load fixtures command will load the fixtures in memory so they are available to the student's route. Earlier, we created the model file. Let's take a look at it first to make sure that everything is set up correctly. In the student.js file in the models folder, we will see this code. If you can see here, the student model has 2 properties called name and age. Update the root index.js file in the routes folder to return the student's model. The root file will return all student records using the findAll method. This will trigger an HTTP GET request at the server at /students. The model hook is triggered when you visit the route. By convention, Ember will then cache these results. Now we'll open the application adapter names as application.js in adapters folder. Set it to the REST adapter. Here, the REST adapter will be used for all routes. It's a type of adapter that assumes that JSON data will be sent via XHR. Edit the index.hbs file in the templates folder. This will display the model information. In this example, we use the each helper to iterate through all the records. Let's go to our server and run the Ember server command. After running, let's go to http://localhost:4200. Here you will see the results displayed. After the page loads, a list of the students' names and ages will be displayed. This data is retrieved from the fixture data that we set up earlier using our mock server. Fixtures are used when testing an application. It is well-known data and can be used for repeated tests. Ember CLI Mirage can be set up to use fixture data. We'll be going over using fixture data with testing in later videos in more detail. Excellent! We just saw how to work with fixtures. In the next one, we'll see how to customize the adapter and serializer. Previously, we learned how to work with fixtures. In this video, we're going to take a look at how to customize the adapter and the serializer. We will start by learning how to work with adapters and serializers. In the end, we'll see how to add new properties to the serializer. Ember Data is very opinionated on how it wants to access data. The adapter has built-in assumptions on what the data looks like. We can use serializers and adapters to change these assumptions. For this video, we'll be building on the student application we created in the previous videos. We'll be using the same application from the previous video. We'll need to edit Ember CLI Mirage to handle a new namespace. In the config.js file in the Mirage folder, update the students route. This will change the endpoint to API/v1/students instead of just /students. In the students application from the previous section, edit the application.js file in the adapters folder. Now let's add a new namespace to this code example. The namespace property is used to prefix requests with a specific URL. In this case, all requests will have API/v1 prepended to them. Let's go to our terminal and start the Ember server now. When you run it, you should see requests going to /API/v1/students. Now let's see a few optional customizations in Ember Data. Ember offers a number of other customizations if needed. Here are a few important ones to keep in mind. The first one is host customization. In the adapter file, you can add a new location where Ember Data should send requests. This overwrites the default location of the local server. As an example, now all requests will be sent to api.example.com. Next is headers customization. Depending on the API, you may need to send specific headers in each HTTP request. You can add this using the headers property. This will add new headers for every request that is sent. If needed, you can also use dynamic information in your headers by creating a computed property. We will now see how to work with serializers. When using Ember Data, serializers format the data that's sent and received from the back-end data store. We can customize this data to fit the needs of our back-end. So, how do we update the IDs? By default, Ember Data expects each record to have an ID. We can change the name of this using the primary key property. Now we'll generate a new serializer file. Let's go to our terminal and run the command. Next, we would update the application.js serializer with the new ID as shown here. This will transform the ID property to _ID when serializing and deserializing data. In other words, when data is sent or received from the server, it will have a primary key that is set to _ID. Let's look at the key4 attribute when working a JSON payload. At times, the data sent back from the server may not be in the correct format. For example, REST adapter expects the JSON payload attribute names in camel case. We can change this using the key4attribute property. For example, let's say that the data sent back from the server is underscored instead of camel cased. The server is returning school_name instead of school name. This can be fixed using key4attribute and decamelize. This will take the model name school name and decamelize it to school_name, so it matches what's returned from the server. Adapters are used in Ember Data to help interpret data that is sent and retrieved from the server. It has a set of built-in assumptions on how the data should look. We can make changes so that we can accommodate the different types of APIs. For example, we can customize the endpoint's path namespace, as well as the host if needed. Serializers format the data that is sent and received from the server. Ember Data expects data to be in a certain format. We can change many things in this data, including the primary keys and the keys in the JSON payload. This is accomplished by adding new properties to the serializer. Great, that's about it for this video. We now know how to customize the adapter and serializer. In the next video, we'll be working with relationships. Previously, we learned how to customize the adapter and the serializer. In this video, we're going to take a look at working with relationships. We will start by creating the models, root, adapter, and helper. We would then signify a one-to-many and a one-to-one relationship. In the end, we will load the fixture data. When working with a data store, you'll need to be able to handle relationships. In this video, we'll go over some common relationships from one-to-many and many-to-one, and also how to use it with Ember Data. As with the other videos, we'll be using Ember CLI Mirage to mock our backend. We'll create a simple one-to-many and a many-to-one relationship. We'll mock a school that has instructors and classes. For every class, there is one instructor. Every instructor will have one or more classes. So we'll create a new Ember application. In this application, generate few files by running these commands. This will create the models, root, adapter, and helper that we'll need for this application. Now let's go to our application directory. In the Mirage fixtures folder, update these two files, classes.js and instructors.js. The classes.js has a list of classes and subjects. Next, we need to create the instructors.js file. As you can see, each young instructor has a list of classes that they teach. Each class has one and only one instructor for that class. Now we can edit the config.js file in the Mirage folder. You can add the new routes. Each one of these endpoints will return the instructor and class data. This is done via sideloading. We'll see an example of a JSON response sideloaded later. When this occurs, the server data store returns records only for one model. Ember then does one or more HTTP requests to retrieve data for the other model. For the simplicity of this example, we'll assume that the data is. Finally, create a new scenario that loads the fixture data for us to use. This will load both fixtures so they can be returned to the Ember client. Now let's open the application.js file in the adapter folder as shown. Set it to REST adapter. REST adapter will be used for this video. Now you can edit the class.js and instructor.js files in the models folder. We need to add the new properties for the model as shown here. In this example, we need to make sure that the class has one instructor. This can be accomplished using the ds_belongs_to method. This tells Ember to look at the instructor model for this property. The instructor has a one-to-many relationship with the class model. One instructor can have one or more classes that he teaches. We can accomplish this using the ds_has_many method, shown in the instructor.js file, and providing the name of the model. Now update the index.js file in the routes folder. Specify it to return all the instructor data. This route uses the Ember Data findAll method to return all the instructor data. Next, we will update the helper file, add1.js in helpers folder. Helpers in Ember are used to manipulate template data. You can pass information to one and return information. In this example, we are doing some simple mathematics. Edit the index.hbs file in the templates folder with the model data. In this template, we're using the each helper to display the instructor's name. To access the class information, another each helper iterates over instructor classes. In each iteration, we display the subject and index class. As the index starts at 0, we can pass it to the add1 helper. This helper increments the number passed to it. Now we will run the Ember server. You should see all the data displayed from the fixture data. Ember uses the ds_has_many and ds_belongs_to methods to signify a one-to-many and a one-to-one relationship. Ember, by convention, assumes that you are using the JSON API adapter. At the time of writing this, the JSON API is a default adapter for Ember Data. It communicates with a server via a well-defined JSON via XHR. Its goal is to be easy to work with on the client and server side while working with a broad set of use cases, including relationships. For the most part, the REST adapter works fine, so I've included it in the book instead of the JSON adapter. Be aware that you can use either to accomplish your goals. This can be changed using the REST adapter instead. REST adapter assumes that all keys are camel-cased and that any data sent is sideloaded. This is done to help developers easily integrate their back-end APIs and data stores with Ember. So this was the last video in this section. We now know how to work with relationships. In this section we understood the functionalities of Ember Data. We then learned how to create, read, update and delete records with Ember Data. Further, we saw how to use fixtures and customize the adapter and serializer. In the end, we learned how to work with relationships. In the next section, we'll see the process of logging, debugging and testing. In the previous section, we learned about Ember models and Ember Data. In this section, we will first learn to use Ember Logger. Further, we will see how to use Ember Inspector and verify deprecations. We will also learn to use acceptance testing and unit tests. In the end, we will test components, routes, models and controllers. Here is the first video of this section. We will see how to use Ember Logger. In this video, we see how to create a simple program to use Ember Logger, and we will check different types of loggers. Ember Logger is a robust type of logging in Ember. It goes beyond the capabilities of imports.console. In this video, we'll take a look at some examples on how to work with it in your application. So let's start. In this project, we'll create a simple program that demonstrates how to use some of the Ember logging capabilities. Let's go to our terminal. As you can see here, this is a new program application. Now you need to add a new index route. This command will create a new index route. Edit the index.js file in the routes folder of the application directory. Here we need to add some new logging. Ember logging gives us 5 different logging options. All these different types of log methods accept one or more arguments. Each argument will be joined together and separated by a space when written to the browser console window. Logger.info. This is the basic form of logging in Ember. It simply logs the values to the browser console. The info logger logs a message to the console as an info message. In Firefox and Chrome, a small eye icon is displayed next to the item, which we will see later. Logger.error. Here the error log prints to the console with an error icon, red text and stack trace. Logger debug. The debug log prints to the console in blue text. Logger.warn. The warning log will print to the console with a warning icon. Logger assert. The assert statement will return an error and stack trace if the value returns false. Fire up the Ember server using the command Ember server as we did earlier. Let's go to our developer tool and open a console. This is the screenshot of output, how it looks in Chrome. The Ember Logger is a more powerful console logger. It's a robust logging tool to make debugging easier. Ember.logger is built in the Ember CLI package. Nice! So now we know how to use Ember Logger. In the next video, we'll deal with Ember Inspector and verifying deprecations. In the previous video, we saw how to use Ember Logger. We'll now see how to use Ember Inspector, its advanced features, and how to verify deprecations. We'll start by installing the add-on to debug your Ember app. Use Ember Inspector to look at the application data, and finally check deprecation warnings and verify them. Let's get started with this new video. We'll first see how to use Ember Inspector. The Ember Inspector is an add-on for your browser that can help you debug your Ember app. In this video, we'll look at some example codes on how to use it. Before beginning, you must install the add-on. It's available for Chrome, Firefox or Opera. Other browsers such as Internet Explorer can also be used via Bookmarklet. First, let's install the browser add-on for Ember Inspector. For Firefox, install the add-ons from the following website. On Chrome, install the add-on from the Chrome Web Store. All other browsers visit the Ember Inspector GitHub page for further instructions. For the purpose of our video, we'll use Ember CLI Mirage to return a simple school model. After creating a new project, run this command. This will install all necessary files so that we can mock an HTTP server. After the add-on for Ember CLI Mirage is installed, we'll go to our application directory and click on our project. We'll update the config.js file in the Mirage folder as shown. This will add an HTTP GET route that our Ember client will connect when retrieving the school information. Next, we'll update the file for the school information in the Mirage/factories/folder called school.js. This file will be used to generate fake names and city data for our fictitious school. Now we will update the default.js file in app directory scenarios folder. This will seed the data that we need from our factories for the application. Let's generate an index route, model, and the REST adapter by running these commands. These files will be used in our application, which we'll discuss in the next videos. The purpose of this application is to return a list of schools. We'll be using the Ember Inspector to look at this data in more detail. Open the application.js file in the adapters folder. Verify that the REST adapter is set. This tells Ember to use the REST adapter with Ember Data. Review Section 7, Ember Models and Ember Data on Ember Data for a refresher on this topic. Next, we will edit the school.js file in the Models folder. This model has 2 properties, name and city. We will now update the index.hbs file in the App Templates folder. Here, the each helper will iterate through every model returned and display the school information. Now update the index.js file in the app routes folder. Now let's go to our terminal and run Ember Server as shown. Now open Chrome and open localhost 4200. Here you'll see a list of schools as illustrated in the following image. Let's open the Ember Inspector and see what it shows. In Chrome, we'll go to Developer Tools. You can access this by opening the console and clicking on the Ember tab. The Ember Inspector shows View Tree, Routes, Data, Deprecations and Info. Let's click on Info in the Ember Inspector. Here Info displays all the library information loaded in this application. This can be really useful in finding out what version everything is using. Next we'll click on View Tree in the Ember Inspector. The View Tree shows all sorts of information about the application. It shows the current routes, templates, models and more. This can be helpful to figure out what's currently loaded on the screen. Now click on Routes in the Ember Inspector. The routes show all the available routes, controllers and templates. Some routes may not be defined but will be displayed, such as loading. Click on $E next to the index route. In the inspector, you can assign instance variables by clicking on $E. Open the console and add a new record using the instance variable $E. We can type the following code in the console window in the browser. $E store create record school name : test school city : Reno. This will add a new record to your data store. The page will automatically update with this information. This is very valuable. You can use this anywhere to help troubleshoot issues. Let's click on Data to see all the model data. Optionally, you can click on any of this data and verify the attributes. You can make changes as well, and it will automatically update the screen. We will now explore deprecations using advanced features of Ember Inspector. Deprecation warnings will be displayed in deprecations as you can see here. Check this to make sure that nothing in your application is deprecated. If deprecation is listed, it will have a link that you can click on to see what you need to do to fix it. Ember Inspector was designed to make the creating and debugging of Ember applications easier. It was created as an add-on for the most modern web browsers. It displays your current application information, routes, templates, data and more. It's an open source add-on and has an active developer community behind it. New features are being added all the time. To request your own, check out the GitHub page here. Here you will see the new feature for add-on. Awesome! So now we know how to use Ember Inspector. We also learned how to verify deprecations and use advanced features of Ember Inspector. In the next video, we'll see how to use acceptance testing. In the previous video, we learned how to use Ember Inspector and verify deprecations. In this video, we will first create a new acceptance test and execute test cases. Acceptance tests generally help test workflows and emulate user interactions. In this video, we'll look at creating a few simple acceptance tests. Let's open the terminal. Here is the path for the new application. In a new application, create a new component called book-shelf using the command Ember G component book-shelf. Create a new acceptance test called add-book-test.js using the command Ember G acceptance-test add-book. This will create the code necessary for the book-shelf component and the add-book acceptance test. Keep in mind that an integration test will also be generated for the bookshelf component. We will not be updating the integration test in this example. We will now update the component file bookshelf.js in the app folder with a new books array and new action. This component uses the books property to keep track of books on the bookshelf. The books property is an Ember array of objects. The add action adds another object to the array. Ember.a is used to declare an Ember array. Next, we need to update the book-shelf.hbs component's template file. The component lists all the books. It also has an input helper and a button. The button has an action called add that gets triggered on the click event. It passes on the value from the input helper as an argument to action. Add the bookshelf component to the application file, application.hbs file. This code adds the bookshelf component to the application template. Add the test code to the add-book-test.js file in the acceptance folder. This acceptance test visits the root of the application at /. It then adds new text to the input helper and clicks the button. It then checks the URL and template to make sure the text was added. The code at the top is mostly boilerplate. The tests are at the bottom and can be followed step by step. The visit, fill in, click, and then helpers are all asynchronous test helpers. The following is a list of all the asynchronous and synchronous test helpers. 1. Click selector. This clicks an element and triggers the corresponding action, and returns a promise that fulfills when asynchronous behavior is complete. 2. Fill in, also known as selector or value. This fills in the selected input with the values given and returns a promise that fulfills when all asynchronous behavior is complete. Key event, also known as selector or type or key code. This simulates key press, key down or key up on the element. 4. Trigger event, also known as selector or type or options. This triggers the given event on the element identified by selector. 5. Visit URL. This visits the route given by the URL and returns a promise that is fulfilled when all asynchronous behavior is complete. 6. Current path. This returns the current path. 7. Current route name. This returns the currently active route. 8. Current URL. This returns the current URL. 9. Find, also known as selector or context. This finds an element starting at the app's root element. Optionally, you can add some context. Let's go to our terminal now and run Ember Server. We will then visit localhost 4200/tests URL. This URL will display all the tests running. Look for the acceptance test for add book. This acceptance test shows that everything has passed. Alternatively, you can also run the tests on the command line by running the code ember_test/server. This will bring up a screen so that you can run tests in your console. To use this, you must first navigate to localhost on port 7357 as shown. This test will then refresh with the number of passed tests. Each test will be checked, and any tests that fail will be shown on the screen. This test will be rerun after any file changes. Acceptance tests are done to test the user interaction and flow. This is done via Ember's QNIT testing framework, although other testing frameworks are supported using third-party add-ons. You can navigate to the /tests URL or run Ember test on the server to execute test cases. So, we saw how to use acceptance testing. In the next one, we'll see how to use unit tests. Previously, we learned how to use acceptance testing. In this video, we will start by testing computed property and later create a unit test. Unit tests are used to test smaller chunks of functionality. In this video, we'll see an example of this. In this example, we'll create a simple Ember.object with a computed property. We'll test this computed property and assert if the value returned is correct or not. In a new project, create a new first-last.js file in the models folder. I have already created a file. In the app-models folder, you can see first-last.js file. Here is the code. In this file, we have two properties, first name and last name. The full name computed property combines these two and returns a full name. If either of these properties change, the computed property will fire. Next, we'll create a new unit test that checks Ember.object and computed property. We'll go to terminal. We'll run a command here, Ember g model-test first-last. The model-test unit test generated will create a new test file in the app tests folder we have in the unit-models directory. Now let's update the first-last-test.js file with a new unit test that checks to see whether the computed property is returning the correct values. The module for is a unit test helper provided by Ember QNIT. This helps us get access to the model that we created for lookup and instantiation. The unit:"true property flags the test case as a unit test. As we are using module 4, we can instantiate the first-last object using this.subject. The test then sets first name and last name of the computed properties and does assert to make sure that they are equal. After the file has been created, we will run Ember server command. After the command runs, we will go to the Chrome and access localhost 4200/tests URL. Scroll to the 12th point unit of the output. this window will appear. Update the first-last-test.js file in the models folder with the wrong value as shown. We updated the code, so now the test will fail because the test does not match. Navigate to the /tests folder again and see the output. Now the test fails because the text does not match. You can see this output by navigating to the /tests folder or running Ember test from the command line. Unit tests are used to test small pieces of code or functionality. They are another part of the Ember QNit library. Unit tests can run for virtually anything in your application, including models, components or controllers. Great, that's about it for this video. We now know how to perform unit tests. In the next video, we'll see how to test components. Previously, we learned how to perform unit tests. In this video, we will start by generating a new component and later test actions in components. Components should be tested using integration tests. In this video, we'll look at a simple example of a component that changes the size of the text. In a new application, create a new component called font sizer. Let's go to the terminal. I won't be running the commands as I've already created a new component. But here is the command. This will generate a new component called font sizer. This component will be used to resize text. Now let's update the fontsizer.js file in the components folder. All the components render as div tags inside of templates. We can add different attributes to these div tags if needed. In this case, the attribute bindings property will add a style tag. The style tag will be a computed property that updates whenever a size value changes. Ember.handlebars.safeString lets Ember know that the string should be displayed without escaping and that it is safe. Next, update the application.hbs file with the new component. Here, the font sizer component is in block form. The test text will be in the div block. Now let's go to the app, tests, integration, components folder. We need to update the font sizer.js file in the component folder, so that we can check to make sure that the attribute was added. This code is automatically generated for us when we created the component. The module for component helper is used for components. The integration::true tags this as a test as an integration test. By doing this, we have the ability to render the component and pass the size property to it. The assert.equal method is used to check whether font-size is set correctly. After our file has been created, we'll go to our terminal and now run the Ember server. Navigate to localhost 4200/tests. We will go to 7th point, which is integration component, where the size if set to 38 pixels. So our test is passed now. Now let's see how to test actions in the font sizer component. We can simulate actions and test the results to verify the expected results. Using the existing application, update the font sizer.js file with a new action as shown. This action will set the text info property to high. Next, we need to update the font sizer HBS file in the components folder in the app directory. In this template, we create a new div tag with an ID of info surrounding the text info property. A new update text action was added to the button click. This action updates the text info property. By setting assert.expect_2, the test must have 2 asserts or it will fail. We first render the component using the this.render helper. The next statement checks whether the value returned from this $info.text equals hello world. We then simulate clicking the button. The last statement checks whether this.$info.text equals hi. We will now run the Ember server and navigate to localhost 4200/tests. Here you can see the starting text is hello world and the second is text changed to hi. All the tests here will pass. Components use integration tests by way of the module for component helper. This feature of Ember's QNit takes advantage of how Ember actually sees your components. You can test bound values as well as the returning actions. So in this view, we saw how to test components. In the next video, we'll see how to test routes, models, and controllers. Previously, we learned how to test components. In this video, we're going to take a look at how to test routes, models, and controllers. We will start by generating a new route, model, and controller. We will then test them. First, we will take a look at how to test routes. Testing routes can be done either by acceptance tests or unit tests. In this example, we'll create a simple unit test for a route. In a new application, generate a new students route as shown. This command will generate the route code for students. We will now open the students.js file in the routes folder. Here we will edit the student's route information and add a new property. This route has a property called someText. Edit the students tests.js file in the tests unit routes folder. In this example, we are checking the output of someText property. The first assert.equal gets the property and it checks against the someText value. The route instance can also set properties. The next assert checks to see whether the new value has been set. The final assert makes sure that the route is available. Now we will go to our terminal and run Ember Server. Next, we navigate to localhost colon 4200/tests URL. Here is our example test. Click point number 13. You can see all our tests have passed. The route in your Ember application has a few different functions. It can hold your model data and have properties and actions. When testing routes, we can use it with a more general acceptance test or as an individual unit test. Now we will see how to test models. When testing models, you can use Ember Data to help. In this video, we'll create a model and test to make sure that it's creating data properly. In a new application, we need to generate a new student model. I am not running this command as I have already created the new application. This will generate the necessary files for the student model. Now let's update the student model with two properties. Go to the model folder application directory, and here you will find the file student.js. This model has two properties, first name and last name. Both hold string values. Next, we need to add a new unit test for the new model that tests the new properties. We will now open the student-test.js file in the models folder. Here is the code for it. This test uses the module for model helper. The first test checks whether the model is OK and it exists. The second test checks the properties. In this case, the first name Eric, last name Hanchet object is created in the store. We can access these values by using the model.get method. The assert.equal method checks against the model to make sure that the values match. Next, we will go to our terminal and run the Ember server. Next, we navigate to localhost 4200/tests. Go to point 11 and you'll see the passing tests. The module for model helper is used to access Ember's model information. This is done with Ember Data so that models can be tested. Ember's QNIT provides a way to test the model completely. Now we will see how to test controllers. Controllers should be tested in your application. Here we'll test some basic actions from a controller. Grab a new index controller by running the command ember g controller index. This creates a new controller called index. I have already created the controller. In the index controller, add a new property and action. The controller has one property named myValue. Another action called pressed changes the value of myValue to whatever value is passed in the function. Update the index unit test file named index-test.js in controllers folder. Add a few tests for the action and property. Here, the module for helper is used here for controllers. The first test checks to make sure that the controller exists. This test creates an instance of the controller with this.subject. The initial value is checked to make sure that it's correct. To send an action to the controller.send method is called. The send method can take one or more parameters. The first is the name of the action to be triggered. This is followed by any values that should be passed in the method. Now let's run Ember Server and navigate to localhost 4200 tests. Go to test number 10. This will display the passed tests. Controller tests are very similar to the unit tests that we discussed before. They use QNIT's module for helper. In a controller, we can test the properties or actions and make sure that the results are as we expected. So in this last video, we saw how to test routes, models and controllers. In this section, we learned how to use Ember Logger and Ember Inspector. We saw how to verify deprecations and use acceptance testing. We also saw how to perform unit testing. Finally, we saw how to test components, routes, models and controllers. In the next section, we'll see real-life tasks with Ember.js. Hi and welcome to section 9, real-life tasks with Ember.js. Previously we saw logging, debugging and testing. In this section we will learn to use services with a component, manage basic authentication, use OAuth 2, create transitions, work with HTML and learn to use Bootstrap with Ember.js. Now we move on to the first video of this section that deals with using services with a component. In this video we're going to take a look at how to create and inject a service into a component. In Ember.js, a service is a singleton object that holds state. In other words, it can be shared throughout an Ember application and doesn't change. For example, session data. APIs that talk to a server, and WebSockets are good candidates for services. Dependency injection services and dependency injection go hand in hand. Dependency injection, DI, occurs when we take objects and inject them into other objects during instantiation. This means that we take a service and inject it into our routes, controllers and components. This is an important framework concept and should not be overused. Having too many injected services would break the separation of concerns using design principle. In a new application, generate these files. These files will be used to create our application. The service will hold a property and method that returns data. Begin by editing the start.js service. This is the services file. It has an isOn property and a method called importantInfo that returns a string. In this example, we want access to the information in our component comp-info so that it can be displayed. Edit the component comp-info.js file and add a new action that uses the start services information. The most important thing in the component is the start property. We can inject the start service into the component by using Ember inject service. By convention, the name of the property must match the name of the service being injected. In our example, the start service will be injected. The press me action toggles the isOn property of the start service. We then set the text returned from the importantInfo method in the message property so that it can be displayed in the template. Add button to the template information for the component. In the component, all we are doing is adding an action to the button and displaying a message. Add the comp-info component to the application template file. Now the template will display the component that was just created. Start the Ember server and it will look as follows. Awesome! Pressing the button will toggle the isOn property. As you can see from this example, the service information was accessed by the component and displayed to the template. Create initializer that injects the service into all the components. Ember.js initializers are created when the application is started. It's a good place to preload data or set up the application state. The app argument in the initialize function is known as Ember.application. It serves as a registry for dependency declaration. Factories, classes, can be registered and injected into the application. The service :start is the key for the start service that we created earlier. Once a factory is registered, it can be injected anywhere in the application. As the start service has already been created, there is no need to register it. The app inject takes 3 arguments. The first is the type to be injected. The second is the name of the service, start. Finally, the service start factory is created. Update the component so that it no longer injects the start service as it's already available via the dependency injection. The start service is commented out so it's no longer available. The rest of the component remains the same as the service can still be retrieved using the this.get start. This is due to the fact that we injected it into all the components in the initializer. Run the server again and the template loaded will remain the same with the same functionality. Nice! Services are long-lived Ember objects that can be used in different parts of your application. They're good to use with sessions, WebSockets, geolocation, logging and more. They can be made available to the rest of the application using Ember.js Service, which is a method that can retrieve services and make them available. DI can be used to inject services into many parts of the Ember application. Ember's architecture uses factories that are registered by Ember application and can inject into all routes, components and controllers using the application inject method. In this video, we have learned how to use services with a component. Nice. In the next video, we'll take a look at how to manage basic authentication. In the previous video, we looked at using services with a component. In this video, we're going to take a look at managing basic authentication. In any real-world Ember application, at some point you'll need to deal with authentication. For example, users might need to send their credentials to identify themselves to the server, or authenticated users may need access to protected parts of the application. An important aspect of authentication is protecting information based on the logged-in user. This can be done by creating sessions with the use of tokens. We'll create a simple token-based authentication with an express server. This will help us understand the basics. In a new application, generate these files. This will generate all the scaffolding that we need for our application. The student's root will be protected. It will only populate information from the server if the user is authenticated. The Ember G server index command will generate a Node Express mock server for us. In the previous chapters, we used Ember CLI Mirage to do all our mock tests. The Express server generated by Ember is not as powerful. However, it will be easier to set up our fake server and authentication example. Be aware that when deploying an Ember application to production, the Ember server will not be included. It will, however, automatically start when running the Ember serve command. Create a new service called Session that will handle our authentication and keep track of authenticated users. This service will be injected into our login controller. This will keep track of authenticated users and send AJAX requests to the server. The authenticate method accepts the login name and password. These values are sent to the server using an HTTP post method to /token. If the user login information is correct, a token is returned and saved. If not, an error will be returned. We'll deal with the error in the login controller later. The token property will be used to keep track whether the user is authenticated or not. Update the express server index.js file. Add a root for token. This is our Node Express server. It will run when we start the Ember server. When the HTTP post /token request is sent to the server, it will check the body, username and password. For this example, we'll just hardcode them as Eric and secret code. If these match, it returns access_token. If not, it returns an invalid message. The access token will be saved in the session service. We can use this token to authenticate future requests to the server. Update the application.js file. Add a new authorization header. In our application, accessing the student's root will trigger a request to the server. The server will respond to authenticated users only. The server expects an authorization bearer header with every Ember Data request. We can do this using the headers computed property and returning the authorization bearer header with the secret token from the service. Every request to the server using Ember Data will send this header. Update the express server index information in order to return information to the application if the token matches. Above app post, you can add app get for the student's root. Ember will trigger this HTTP GET request whenever it enters the student's root. The server will check whether the request has the secret code. If it matches, it returns the proper JSON data for the student's root. If not, it returns a 401 error. Verify the root and model information for students. Earlier, we generated this file with two properties, name and age. The student's root will send an HTTP GET request to /students to retrieve the student's model. As we define the application to use the REST adapter, Ember will expect the data in the REST format. The student's template uses the each helper to iterate through the model returned from the server. It displays each name and age. Add the login username and property to the login template. This template uses the input helper for the login name and password properties. The button triggers the authenticate action. Update the login controller to handle the authenticate action. The controller has several properties. It retrieves the session information service and uses the authenticate method to send the login information to the server. The authenticate method returns a promise. If it's successful, the application transitions to the student root. If it's not successful, an error is displayed in the alert box. In this example, we are using the ES6 arrow function. The arrow function is a little shorter than using a function expression, and it also lexically binds this variable. Update the index with a link to log in. This is just a simple link to the login route. Start the server and navigate to the login route. You'll see the following image. To log in, enter the username Eric and the password password. After clicking login, an HTTPS post request will be sent over to the server and the name and password information. The Express server that we had set up earlier will respond with the token, and the session service will save it. The application will then transition to the student's route. The following screen will be displayed. Excellent. When this route loads, an HTTP GET request will be sent to /students. The Express server will check to make sure that the authorization bearer header has the correct secret code. It will then respond with the JSON data that Ember will display. If the username and password does not match, the following alert box will be displayed. Token-based authentication requires the client to send over credentials to the server. If authorized, the server then sends back a token that the client saves and uses on subsequent requests to the server. If the token is not present, the server may not return data to the client. This video is a simple example of using authentication. It lacks proper error handling and session persistence. Nevertheless, it gives you an idea of how authentication works. In this video, we have learned how to manage basic authentication. In the next video, we'll learn more about using OAuth 2 with Ember Simple Auth. In the previous video, we looked at techniques to manage basic authentication. In this video, we'll look at using OAuth 2 with Ember Simple Auth, ESA, a robust add-on for Ember. OAuth 2 specifies authorization flows for web applications. We can use it with Ember to secure our application and provide data only to those users that are authorized. ESA will handle our client-side session and authentication and send the requests to the server. It's very customizable and extensible, although it can be complicated, just like our last video. We'll create a protected student's route that can be accessed by authorized users only. For the purposes of this example, we'll need an OAuth 2 server. Setting up an OAuth 2 server is beyond the scope of this video. There are several OAuth 2 libraries out there that you can use. To set one up, I recommend the following: Rails, https://github.com/doorkeeper-gem/doorkeeper, Express, https://github.com/thomas seddon/node-oauth2-server. In a new Ember application, run the generator command to create the required files. This will generate the scaffolding that we need to begin our application. The last command installs the add-on for ESA. 2. We'll begin by setting up the Ember Simple Auth authenticator and authorizer for OAuth 2. We need to set this up so a user can authenticate with the server. Create 2 new directories in the app folder called Authenticator and Authorizers. 3. Add a new file called auauth2-custom.js to the Authenticators directory and application.js to the Authorizers folder. Add this code. This Authenticators file is used by ESA whenever a user logs in. We can overwrite anything in the Authenticator if needed. The make_request method is used to send messages to the server. By default, ESA will make an HTTPS post request to /token with the username and password in the form field. 4. Unfortunately, many OAuth 2 servers require a header called authorization basic with a secret client ID and client secret when authenticating for the first time with the server. To fix this, we can extend the make_request method with our own AJAX request. This will be used when we log in. The authorizers file is used by ESA to tell which type of authentication we are using. In this example, we are using OAuth 2 as defined by OAuth 2 bearer, extend. Update the adapter and add the ESA data adapter mixin to the application.js file in the adapters folder. This adapter tells Ember to make all requests to the /API namespace. The ESA data adapter mixin is used to define the authorizer that the application will use. In this case, all Ember data requests will use the OAuth2 application authorizer that we defined earlier. In other words, any request sent to the server using Ember Data will include session data token if it exists. Let's update our login-comp component template. This will submit the login and password to the authenticate action set up in our component. Update the login page component with the authenticate action. As we are using ESA, we have access to a session service. This session service has an authenticate method that uses authenticator that we created earlier. In the preceding code, we used this.get method to get login and password from our template. We then called the authenticate method on our service, passing in our authenticator. If the server returns a successful message, then we call transition, a method that is passed to the component. If not, an alert box pops up telling the user that their login was not successful. Add the login page component to the login template and update the login controller. This calls the login component and passes in the parent action, logged in. This action transitions the application to the student's root. It's triggered only with a successful login. It's also the name of the action passed in the login page component. Update the student's controller, root and template. The template displays the information from the server using the each helper. A logout button action will log the user out. The logout action invalidates the session. Invalidating the session revokes the token so that it's no longer available. This root returns all the information for the student model. You'll notice that authenticated root mixin is added. This tells Ember to make this root available only if it's authenticated by the server. If it's not, it'll route back to the application. Add the application mixin to the application root. ESA's application root mixin will catch any errors and transition to the login route. Update the index template with a link to the login route. The link to helper links to the login route. Start the Ember server and OAuth2 server. The --proxy argument tells Ember to proxy all server requests to localhost at port 3000. We'll assume, in this example, that OAuth2 server is running on port 3000 in your local box. A successful login will look like this. It will then redirect to the student's root. This root will send a request to the server with an authorization bearer request with the correct token. It will receive the student data, so it can be displayed to the user. Accessing this root without being logged in causes redirection to the login page. Great! The Ember Simple Auth add-on manages the session authentication, authorization, persistence and communication with the server. It has its own built-in session service that makes it easy to manage. OAuth2 is a specification of a type of flow when doing authentication in web pages. As Ember is a single-page application, there is not much security on the application side. It must rely on a server to authenticate and manage tokens. ESA makes this possible by handling all the work needed to send and communicate with the server. In this video, we learned in detail about using OAuth2 with Ember Simple Auth. In the next video, we'll learn about using Liquid Fire to create transitions. In the previous video, we learned in detail about using OAuth2 with Ember Simple Auth. In this video, we'll learn about using Liquid Fire to create transitions. We'll also create a few transitions to see how this add-on works. Ember Liquid Fire is an add-on for Ember that handles animations and transitions. It's a toolkit of sorts that splits its responsibilities between template headers, transition maps, and transitions. In a new Ember application, generate these files. This will generate scaffolding for the tut1 and tut2 routes as well as install the Liquid Fire add-on. Create a new transitions.js file in the root of the app folder. Add a few transitions. Liquid Fire requires a transitions map file. There are a number of predefined transitions that you have available. Each one behaves as you would expect. The to-left transition will create a transition animation where the page moves from left to right. The to-right transition is the exact opposite. You can also create your own animations if needed. The map tells us which transitions to use when moving from one route to another. Update the application template with the liquid-fire outlet. To use liquid-fire transitions, we must use liquid outlet. This is used when transitioning between routes. Here are all the template helpers available. Liquid outlet. This transitions between routes. Liquid with. This transitions between models or context in a single route. Liquid bind. This updates to simple bound values. Liquid if. This switches between true and false branches in an if statement. Liquid spacer. This provides a smoothly growing / shrinking container that animates whenever the contained document object model, DOM, mutates. In the index template file, add a link to the tut1 route. The link to helper transitions to the tut1 route. The liquid outlet will display the tut1 route when it renders. Update the tut1 and tut2 routes templates. All this does is have a link to the second route's tut2. This has a link back to tut1. Run the server and you'll see the transitions as you click the links. Awesome! This is what it looks like mid-transition using crossfade from one application route to the tut1 route. Liquid-fire is a versatile add-on for Ember that brings transitions and animations to life. It uses a simple transition map and template helpers to make things easier. Under the hood, Liquid-fire uses many tricks to make these animations possible. It's extensible, so you can create your own transitions as well. In this video, we learned in detail about using Liquid-fire to create transitions. In the next video, we'll learn to work with HTML5 and take a look at examples of drag and drop. In the previous video, we looked at how to use Liquid-fire to create transitions. In this video, we're going to take a look at HTML5 drag and drop. Drag and drop is part of the HTML5 standard. It allows the user to grab objects in the DOM and drop them at different locations. Any element can be draggable if the browser supports it. Most modern browsers do. We'll see an example of dragging an IMG file to a drop zone on the screen. In a new application, generate these files. The drag-drop zone component will represent the area where each item will be dropped. The drag-drop component will be the item to be dropped. Edit the drag-drop zone.js file. The component has a few special events attached to it. Ember has built-in events for drag leave, drag over and drop. These will fire whenever items are dragged on top of the component. Remember that all components render as div tags. We can use the class names property to add more classes. The class name bindings property allows classes to be added to the component as if they were properties. In other words, drag class can be set dynamically in the component. We'll use this to change the color of the drop zone when items are dragged over it. When items are dropped, the drop event is triggered. Update the drag-drop component. As mentioned earlier, normally components render as a div tag. However, we can change this using the tag name property. In the drag-drop component, we are creating an image tag. The drag start event available in Ember. In this example, we are setting the data to the target ID. To drag items in HTML5, you must have a draggable attribute on the tag. It also must be set to true. We'll use attribute bindings to make this possible. Update the app.css file. This is some basic CSS that creates a border around the drop zone and changes the color to red when an item is about to be dropped. The last step is to add the components to the application template file. This will render the two components to the application template. Render the page and you'll see the picture and drop zone. You can drag the picture into the box. The box will turn red before the item is dropped and back to black after it's dropped. The HTML5 standard allows dragging and dropping elements. Ember has several built-in events that we can use in components and controllers. The drag leave, drag over, drop and drag start methods can all be used to capture events to allow dragging and dropping. In this video, we've looked at how to use HTML5 drag and drop with Ember Fire. In the next video, we'll learn to work with a bootstrap. In the previous video, we looked at HTML5 drag and drop. In this video, we're going to take a look at bootstrap Bootstrap, formerly known as Twitter Bootstrap, is a popular, free and open source collection of tools to create websites and applications. It contains several templates for typography, forms, buttons and navigation. You can use Bootstrap to make nice and simple user interfaces. In this video, we'll use it to create a drop-down menu. In a new Ember application, use Bower to install the latest version of Bootstrap. This uses Bower's front-end package manager to install Bootstrap. It will be saved as a development dependency in the bower.json file. Update the Ember-CLI build.js file and add the libraries for Ember Bootstrap. The app import statement takes the asset path as the first and only argument. This is standard for non-AMD assets. Once this is loaded, we can use Bootstrap anywhere in our application. Add a drop-down button to the application template. This will add a drop-down button. Start the server and you'll see the rendered button. After clicking on the button, the menu will be displayed. Let's install the Bootstrap Ember add-on and comment out app imports in the Ember CLI build.js file. Ember Bootstrap is an add-on that includes all the normal CSS and icon assets in your project. It also includes a set of native Ember components. It does not use the Bootstrap JavaScript file. As we are using the add-on, we must comment out the Bootstrap files. They are already included. Update the application template using the new Ember Bootstrap components. All the Ember Bootstrap components start with BS. The BS-dropdown component creates a drop-down menu that displays links to the user. Using Ember Bootstrap can be a little cleaner and easier than installing Bootstrap with Bower. Load the server and you'll see the following image. This is using Ember Bootstrap to create a menu. Bootstrap is a versatile set of tools that can help you design a front end quickly. Ember accepts assets using a library called Broccoli. Broccoli is an asset pipeline. It helps build the application. The app import statement is used to bring AMD and non-AMD assets in the application. On the other hand, the Ember Bootstrap library can also be used. It has easy-to-use components built in that make it easy to add buttons and menus. In the next section, learn in depth about Ember validations. Hi and welcome to the first video of this section. In the previous section, we saw real-life tasks with Ember.js. In this section, we'll use Ember validations, then we'll use Ember.js with d3.jus, sockets, and finally we'll use server-side rendering. Now we move on to the first video of this section that deals with validations. In this video, we'll take a look at two examples on validation. In the first example, we'll use a component and check data based on a few simple validation rules. In the second example, we'll use a popular Ember add-on to make things easier. Data form validation is a very common use case in web development. The end user will know immediately if they've made a mistake when you create validation rules in your application. As I said earlier, we will take two examples in this video. So let's begin with the first one. So to start with, in a new application, create two components and install the validation add-on. The val-example component will be the first example. The val-example2 component will be the second example using the Ember-cp-validations add-on. So now we first update the val-example.hbs component template file. This component asks for an age. If the button is clicked, the check action will be triggered. So simple input helper is used to capture the input. The error property displays the error text. Next we go to the val-example.js component file and add a check action and simple validation method. The check action calls the validation method. So what is the purpose of validation method? Its only purpose is to return true if the value is a number and return false if the value is not. This result is used to set the error property that will be used in the template. This is a fairly simple example. It shows what you might need to validate the field. So can you guess what could be another example? So it might be creating a new computed property and have it depend on the num property. Either way will work. Now we add the component to the application HBS template file. Next we run Ember Server and enter a non-numeric value in the text box. The window will be displayed on your screen. The error in box message is displayed because a number was not entered. That was triggered after the check button was clicked. In the next example, we'll use an Ember add-on instead. So let's move ahead with the second example. Update the val example2.hbs template file so that it can accept an email and number. The second component is a little more complicated than the first. We'll be validating two form fields, a number field and an email field. In addition, we'll be surrounding the message in a div tag that will be used to help set color of the text. Both fields will be validated after pressing the check button. Now, create a new validations.js file in the components folder. So why is this file needed? We need it for the Ember CP validation add-on and to define our validation rules. We begin by naming each property and defining the validations needed. We can validate many types of different inputs. A list of these validations can be found here. The validator comes with several pre-built messages. We can override these messages by setting the message property. In the preceding code, the num and email validators have custom messages. Also, the num validator checks to see whether any value is in the field and whether it's a number. The email field checks to see whether the value is in the format of an email address. Now add a new check action to the component. After setting up the validations file, you can add it to the component as a mix-in. Once you've added the validations mix-in, you'll have access to the validate method. This is a promise that returns after it validates the fields. The validates have an isValid property. This will only return true if both properties, num and email, pass validation. Now we can check each individual validation as well. We can also access the model properties in the component. This model will have both the num and email properties. We can use isValid to check whether the validation failed. If it did, we can set the message we created earlier with num.messages. In the preceding code, if the validation is not valid, then we set the error message that will be triggered in the template after the check action is triggered. This add-on is very flexible. We can create our own custom validations if needed. Now we update the application HBS file with the second component, and also display the second component example in our application template. So let us now start the Ember server and enter invalid values for age and email, and click on the check button. Now you can see this image will be displayed on your screen. After clicking the check button, an action is triggered. The validators we created earlier check the text and return whether the text is valid or not. In this instance, the text is not valid, so it displays an error message. So before we finish this video, let us understand how it worked. Data form validation is an extremely important feature of any web app. Any Ember application that has any type of user forms will need to validate data. Ember.js can retrieve data from templates and validate it. Other properties can be used to toggle or set error messages to be displayed. We are lucky to have an Ember CP validations add-on which makes this process easier, so you can create your own validations or use some of the built-in ones. This code uses computed properties and other methods to validate and report back issues to the user. You can also check out this website for more information where you will find several other popular validation add-ons available for Ember. In this video, we used a component to check data based on a few simple validation rules and learn how to use Ember add-on. Excellent! In the next video, D3.js in Ember.js. Previously we saw Ember validations. Now we move on to the second video of this section that deals with the use of D3.js in Ember. In this video, we will use D3 in Ember.js by importing it as a library using Bower or using it as an add-on. D3.js is a JavaScript library used to manipulate document data. It can be used to create shapes, animations, and powerful visualizations. It uses web standards such as HTML, SVG, and CSS to accomplish these goals. Ember.js can use D3 by importing it as a library using Bower or using it as an add-on. We'll be trying it out using Bower. However, you can install the popular Ember-CLI-D3 package instead and get some extra functionality. So, if you have a new application, run these commands in the application folder. The bower command will install D3 and set it to the bower.json file. The component will end up holding all our D3 code. Edit the Ember CLI build.js file and add the D3 file. This file is where we can add all our third-party libraries. So add D3. We have to add the app import statement pointing to the directory where the D3 library is. At this point, D3 will be available to use anywhere in the application. Now, open the D3 code.js template file and add a div tag. This will be our placeholder for the animation we'll be creating later. Next, what you need to do is edit the D3 code.js file in the components folder and add a new circle animation. This component's purpose is to use D3 to create a new SVG tag and a new circle object in it. To accomplish this, we want to render it on screen after the component loads. Ember.js views have didInsertElement, willInsertElement, and willDestroyElement hooks. These all correspond to different points in the component's application lifecycle. The willInsertElement hook takes place after the view has rendered, but before it has been inserted into the DOM. The didInsertElement hook occurs after the view has been inserted into the DOM. It's the most useful hook to use when dealing with third-party libraries such as D3. The willDestroyElement hook is called before the element is removed from the DOM. This is a good place to put code that removes event handlers that you might have added. Whereas the SVG container variable creates the SVG tag and appends it to the div holder we created earlier. The circle variable appends the circle tab that will be animated. Now add the component to the application template. This adds the component to the application template so it can be rendered. Run Ember Server and you'll see the circle move from one side of the screen to the other. The circle will move from the top left-hand side corner to the bottom right-hand side corner after the page loads. This occurs after the component is completely rendered on screen. D3 uses web standards to generate powerful visualizations. Ember can import any third-party library using the built-in Broccoli library. Once a library is loaded, it can be accessed throughout the application. We can use the didInsertElement hook in our view to manipulate the DOM. D3 will render a circle on the screen and animate it. Awesome! So we learned how to use D3.js with Ember.js in this video. In the next video, we'll use Ember with Socket.io. In the previous video, we learned how to use D3.js with Ember. Here we're using Ember with sockets. In this video, we're going to take a look at using WebSockets in Ember with the use of add-ons. WebSockets make it possible to open a communication session with a server. Ember.js does not handle this natively, however, there are some easy-to-use add-ons that can be used to make this possible. First, in a new application, install the WebSockets add-on. Generate a new root. Then let us install the component root and add-on that we need to begin. Then in the components template folder, edit the w-s.hbs file. In this template, we have a message property and a button that sends an action, send button pressed. When the action is triggered, a message is sent to the server. The message property will display any messages returned from the server. Let's update the w-s.js component file so that it can handle the action from the template. The add-on installs a service called WebSockets in the application. It can be accessed by injecting it into the component using Ember inject service. As the property name matches the service name, we don't need to specify the service name in the inject statement. Now, to begin, we'll set up the init function. The init function is a component is called on when the object is instantiated. You can override this by setting up your own init. To make sure that nothing odd occurs, we must call this .super, so that Ember sets up the component correctly. The socketOn method creates 3 events called open, message, and close. So during instantiation, these 3 event handlers are created. The first one handles events that occur when a connection is made with the server, whereas the WebSocket service can be set up using the socket4 method. This tells the service where the server is located. When the connection is established, a message is logged to the console. The second event is triggered when a message is received from the server. After a message is received, it's set to the message property. The last event is triggered when the connection with the server is closed. This logs a message to the console. Now the send button pressed action creates a message and sends it to the server. After the action is triggered, we use the existing socket property to send a message out to the server. Add the WS component to the ws.hbs root, and this component will render at w-s. Load the server and navigate to the w-s root, and then you'll see the following message. This message displays the values from the server. Pressing this button sends a message to the server. You can see how we can take this simple example and create a complete chat server. WebSockets helps facilitate communication between a server and browser. The browser can send and receive data over sockets. This can be used with event-driven messages or APIs. You should also know that there are a great many ways to implement a WebSockets server. A great way to do this is to use the WS library. In the following steps, we'll create a basic WebSockets server to use with this video. Now create an empty directory and run this command. Next, follow the prompts and create your project. After this, install the WS package, and this will install the WS npm package, and save it to the package.json file. Then create a new server.js file. Create a simple WebSockets server. Now we are ready to start the node server. This server creates port open at 7000. It then waits for a connection. If it receives a message, it outputs to the console and returns a new message. This will be displayed in the Ember template file and received by the message handler. In this video, we have used Ember with sockets. Excellent. In the next video, we'll take a look at using server-side rendering. Hi. In this video, we're going to learn about using server-side rendering. In the previous video, we learned how to use Ember with sockets. In this video, we're going to take a look at 1. Installing Fastboot, 2. Building application for production, 3. Running the Fastboot server. Ember.js runs in the browser. It uses JavaScript to handle all the routing and rendering of data. It only talks to the server on the initial page load and to retrieve JSON data. This can have some limitations. Larger applications might take longer to load on slower connections, and there is still some concern around search engine optimization. To help alleviate these concerns, the Ember team created Fastboot. Fastboot is an Ember CLI add-on that allows Ember.js to render and serve applications on the server. It's a work in progress as of writing, and this has some limitations. It's not recommended for production, and doesn't work with jQuery or did insert element. It will be hopefully production ready by Ember version 2.4. Nevertheless, it's improving and is an important add-on for Ember. In a new application, run these commands. Fastboot requires the Canary version of Ember to work. We must delete the bower_components folder before installing. Remove it by typing this command. So, after running the command here, I've got the message unable to find a suitable version for Ember. Please choose one by typing one of the numbers below. Here I'll choose Ember #canary and then type 1. Great, we've installed Ember #canary. Now we need to build the application for production. This command will build the production server and minify all the files. So here our project has been successfully built and is stored in the application folder dist/file. Next, we need to run the Ember Fastboot server. This will run the Ember Fastboot server. Let's break down these arguments. --serve assets. This serves the assets out of the dist folder. --port 4200. This specifies the port. The default is 3000. In this case, we can use 4200 to match the test server that we normally use. --environment production. The default is development. Use production. It works better as Fastboot is faster with minified files. Now, we'll open up localhost at port 4200 to see the web page load. The page doesn't look any different. However, if you look at the browser console, you'll notice that the Ember application rendered without downloading all the JavaScript it normally needs to run in the browser. Great! Ember Fastboot is an Ember add-on that's being worked on. As of recording this, it has a lot of limitations. That being said, it will eventually allow you to render your Ember.js application on the server, or at least part of the application. for the initial page load. This will help reduce page load time significantly. To learn more about Ember Fast Boot, check out their website at https://github.com/tilde/ember-cli-fastboot. So, this is all about using server-side rendering. Cool, isn't it? In this section, we have learned how to use Ember validations. Then we saw how to use D3.js with Ember.js. Then we used Ember with sockets. Finally, we saw server-side rendering. Awesome! So, that marks the end of this course. We started off with basics of Ember, and now we know everything we need to know to build a fully operational Ember application. I really had great fun in developing the course. I hope you enjoyed it too. All the best.